Okay, it looks like we are live here on Standing for Truth. I want to welcome everybody to the program today. My name is Donny, and I am your host for this important show on the flood and post-flood boundary. It is a privilege to have Michael J. Oard back with me for a presentation and discussion on this somewhat controversial topic. Again, we will be answering the specific question: where is the flood and post-flood boundary? Now, there exists several different young Earth creationist positions on the boundaries question. And these positions include the late Paleozoic, the Cretaceous / Tertiary, and the late Cenozoic. Which position is best supported by the data? And this is one of the many questions we are going to be addressing in this crucial program. Now, Mike Oard, he's been here many times before, and he's been a huge blessing to this ministry. As a matter of fact, this is his 9th time here on the program, and all of his previous presentations are linked in the description box for people to check out. You'll find presentations and discussions on the receding floodwaters, the Ice Age, answering challenges and refuting objections to the Genesis flood, the Green River Formation, the Grand Canyon, and more. Now, before I hand it over to Mike for his presentation today on the flood boundary, as always, we will be also engaging the audience. So if you do have questions, let's keep it on topic as much as possible. Please make sure to tag me. You can tag me either at Standing for Truth or at Donny, just something for me to be able to see it. And I'll make sure to save it, and we'll have some time for discussion. Now, I do want to give Mike a proper introduction here. Michael has a master's science degree in atmospheric science from the University of Washington and is now retired after working as a meteorologist with the U.S. National Weather Service for 30 years. He has researched and speaks on the compelling evidence for Noah's flood and the ice age that followed, and how the incredible woolly mammoth connects to biblical history. Michael has published many papers in his field in widely recognized journals and has written an ice age caused by the Genesis flood, ancient ice ages or gigantic submarine landslides, the Missoula Flood Controversy, and the Genesis flood and the frozen record. He is also author of Frozen in Time, the Weather Book, and Life in the Great Ice Age. You can also find more from Mike in the description box. You can see the links that I have that'll take you right to his website and also his articles on creation.com. So with that, Mike, it's a pleasure to again have you on the program. Thanks so much for giving us your time. And I think we're just going to get right into it. I'm going to hand it over to you.
Okay. Thanks for inviting me.
My pleasure, Mike. Looking forward to this. The audience is as well. It's an important topic, and I've just put your slides up on the screen. So if there's anything you wanted to add in terms of introduction or just get right into it, it's up to you, Mike.
Let's get right into it.
Okay, sounds good.
Well, this is a topic that I've been working on for 30 plus years. It's controversial, but I don't think it's all that controversial to me anymore. I'm looking at other controversial issues like the pre-flood flood boundary more. But anyway, since we have some of our critical friends viewing this, I want to say a few words to them before I get started. Yeah. When it comes to the flood, I'd say we have the big picture in sediments and fossils. Oops, I need to go back. Oh, well, no, I'll go forward. And anyway, it could see this from Grand Canyon in that you find many of these layers extend for hundreds of miles, sometimes thousands of miles from Grand Canyon here. And the flat layers represent a sequence of approximately 250 million years in the secular time scale, but they're dead flat one on each other. Also, there's a planation surface at the very top, which represents maybe about 8,000 to 10,000 feet of erosion We know that from the Grand Staircase to the north. Anyway, you can trace some of these strata, like I said, hundreds of miles. And for instance, the Tapete sandstone at the very bottom, it's a coarse-grained sand with small cross beds in it, like this, and it can be traced over half of North America. It can be traced up in the Canadian Rockies and then the northeast Canada. So it covers half of North America, about 100 to 300 feet thick, almost pure sand, not too many shale interbeds. This is a signature of the flood. Secular scientists or uniformitarianism has small processes, so river erosion, hurricanes. They end up in local, at best regional strata. But strata that cover this large of an area is more of a signature of Noah's flood. And up in my area, the Tapete sandstone is called the Flathead sandstone because different workers in different states gave it different names. But it's the same coarse-grained sandstone sitting on the granites of the upper crust. Has a unique location, so we can't get really confuse it. So, and then you notice that those layers don't show erosion in them. And yet erosion on a million-year timescale is so fast that all of North America can be eroded down to sea level in 10 million years. And the main erosion is in the higher mountains, but as the mountains lower, the erosion rate decreases. So 10 million is a maximum. So you can put some other estimates on it and get probably the slowest rate would be about 50 million years. Here's a summary of it. Some of the other processes, like erosion rate decreases as mountains eroded, max 50 million years. Well, if that's the case, that 250 million year horizontal strata, first of all, it should have been eroded many times. And if it didn't, it should have lots of valleys and canyons cut in it if it was actually deposited over millions of years. For instance, here's a little schematic of Grand Canyon, 200 approximately air miles wide. This pattern here on the bottom, hopefully everyone can see my cursor, is the granite of the upper crust or gneiss, metamorphic rock. And here's 4 layers suddenly laid down on this quickly. Then say in 50,000 years, it would look like that in a subaerial environment. And then say it dropped below the sea level again and then covered up again. The valleys would be filled up and it'd be thinner on the ridges and so on and so forth. That's what you should see in the walls of Grand Canyon if it was just a sequence of 1 million years of deposition. But you don't. You see horizontal layers, sometimes the same thickness through the whole canyon, sometimes thinning, thickening, just slight changes. And by the way, this is not unique to Grand Canyon. You see it in a lot of other places, like this is the Southern Teton Mountains. And you see some horizontally strata here in the Southern Tetons. This is the Central Tetons. That's probably Grand Teton there, which is granite and gneiss that's uplifted 30,000 feet as the granite dropped in Jackson Hole, 30,000 feet at the Teton Fault. And it was covered by sedimentary rocks. And in the North and the Southern Teton Mountains, they weren't completely washed off and eroded. So this strata up here matches the bottom 2/3 of Grand Canyon. Not exactly, but almost exact. And 3 geologists commenting on that sequence said the regularity and parallelism of the layers in well-exposed sections, which I showed you, suggests that all these rocks were deposited in a single uninterrupted sequence. Yeah, that's what we observed because there's no erosion between the layers or within the layers. But they don't believe it because the fossils have stretched out the time scale about 200 million years. And they say, however, the fossils and regional distribution of the rock units show that this is not really the case. So what they're trying to say is that we're not going to believe our observations, our eyes, because there should be erosion in those sequences. But no, we'll have big gaps. There's a gap of 80 million years of missing time in that sequence I showed you, but no erosion at the gap, no canyons, no valleys. So this is, I believe, strong, powerful evidence of the Genesis flood as a real event in the strata, where the strata covered large areas when it was deposited, and one layer was laid rapidly, one on top of another in an uninterrupted sequence. And the fossils, there's hundreds of billions of fossils in there. Fossilization is a very rare event today. And the fact that we have so many things just reinforces Ken Ham's saying of billions of dead things buried in rock layers laid down by water all over the earth. And when we look at the details of some of these fossils, they're found sometimes in big graveyards. 95% of the fossils are marine creatures, mostly mollusks. And by the way, here's a graveyard of ammonites from Venezuela. We have some big dinosaur graveyards of thousands of individual dinosaurs, sometimes with the same species, very unusual. Anyway, 95% of creatures are marine, mostly mollusks, and a large percentage, I don't know the exact, whether it's most or a large minor percent, but a large percent of them are closed shells, indicating rapid deposition of the strata worldwide. So these are powerful, big picture evidences of the flood from the strata and the fossils. So with that introduction for our skeptical friends, let's get on to the main talk. First of all, what is the importance of finding the flood boundaries? Well, we want to develop a comprehensive flood model, and we need to know what rocks occurred after the flood and what occurred during the flood, what occurred before the flood also. But we're going to focus mainly on the upper boundary in this talk. And we want to know what sediments and organisms occurred after the flood, and to know what rocks are from the flood and better understand flood catastrophism, whether before in the flood or even after the flood, as some creation scientists believe. There's generally mainly two locations for the boundary, near or at the KPG. And they have to believe that most, if not all, the Cenozoic is post-flood. The Cenozoic is generally the same as the Tertiary. Or the late flood Cenozoic position, defined, and this is important because a number of creation scientists in this controversy have mischaracterized my position. I define the late Cenozoic as the Miocene, Pliocene, or Pleistocene. And I base it on numerous earth science criteria. And here's a geological column to orientate us. The Cenozoic is this area right here. It includes the Tertiary and the Quaternary. Quaternary includes the Holocene and the Pleistocene. And the Tertiary is now subdivided up the Neogene and the Paleogene. And even further in the system, this is Pliocene, Miocene, Oligocene, Eocene, Paleocene. And I generally would favor the boundary right up in here of that arrow. And it could be lower or above, because we can't be precise using secular geological column time slots for a biblical top of the flood. Because one thing, they keep changing the dates on these things, as I will show later. Here is the other position, the KPG or the KT boundary right here. And there's one that some have claimed way down in the upper Paleozoic, or even lower. But I don't think too many creation scientists are following that right now. And I haven't heard anything from it for over 10 years or 15 years. So these are the main positions, the KPG and the late Cenozoic. So what type of evidence do I have? Well, I have evidence from sedimentary rock, organic evidence like coal, tectonic evidence, vertical uplift of mountains and sinking of valleys, geomorphological evidence, climate and miscellaneous evidence, and some creation scientists use fossils to say that the boundaries at the KPG, and that's fossil evidence that they would use. And I've gone into their fossil evidence. But I might add right now that I have 33 evidences here, and Tim Clary has added 2 more new ones and reinforced some of mine. So we have 35 types of evidence that's in the late Cenozoic. And those that believe that the fossils say it's to the KPG have really never seriously dealt with these yet. And I don't know whether they have not read it or just ignored it or just totally don't know what to say. But if they persist in believing in the KPG, they need to address these 35 evidences, which I am going to present to you right now. We'll start with sedimentary rock evidences. And there's approximately 7 of these, the huge volume of Cenozoic sedimentary rocks. And then we have thin, widespread layers of Cenozoic rocks. Another indication is that flood rocks are normally consolidated. Post-flood rocks are normally not consolidated. This is a general rule. And by the way, we use multiply criterion because no one rule, or at least some of these rules, are not definitive. Like consolidated rock, you can have consolidated post-flood rock, and you can have unconsolidated flood rock. But in general, flood rocks are consolidated, and post-flood rocks are unconsolidated. And then you have Cenozoic evaporites that are either thick or widespread. I'm going to show examples of some of these as I go. Phosphorites. Phosphorite is defined as over 19% phosphate in the sediment, which they believe comes from pulverized organisms. And there's some thick phosphate layers, like in my area of southwest Montana, we have the Phosphoria Formation that is in the top of the Paleozoic. It's over not only southwest Montana, it goes into Utah, Idaho, Wyoming, so it's fairly large. Carbonates, and then thick continental margin sediments. These are all sedimentary rock evidences that indicate the Cenozoic is from the flood. Let's talk about the huge volume. The Tertiary volume, or Cenozoic volume, is greater than any other period of geological time. There's a huge amount of sedimentary rocks in this. Some basins that have Cenozoic strata are thousands of meters thick. Many basins in the Rocky Mountains. There's one basin, the South Caspian Basin, that has 20,000 meters of Cenozoic strata. Now I ask you, if you believe that this thick strata could come about by post-flood catastrophes, how is that? How can that even possibly be? Anyway, here's a plot by geological periods of sediments. And you can see that the Tertiary has the most sediments. Cretaceous is second. Quaternary, which is the Quaternary and Tertiary, remember, make up the Cenozoic, but the Quaternary is mostly post-flood, so you wouldn't expect much sediments in that from a biblical Earth history. So it's a huge amount of Cenozoic strata, as we see in various places on the earth, and sometimes thickly in basins. Now, we have widespread thin sediments that are Cenozoic. And how would these occur after the flood? That's the big question. Could they be explained after the flood? I don't think so. For instance, in my area here of Montana and adjacent North Dakota, we have the Fort Union Formation. It's 450,000 square kilometers and is about 300 meters thick. How can that be spread thinly over such a large area? What is going to do that? No post-flood catastrophe that I can think of could do this. The Ecological Formation in the central and southern high plains once covered 1.5 million square kilometers and varies from 1 to 245 meters thick. I'm going to show you some pictures. Here's the Fort Union Formation. The red area is the current locations of this formation. The hatched area is where it has been eroded from. So what processes could possibly deposit these sediments like this after the flood? I don't think it can occur. They're not as big as like the Tepete sandstone and the Coconino sandstone from Grand Canyon, but they're still a fairly large size that would be best placed in the flood. Here's a picture of the Ecological Formation. The dark brown area is where it exists today. The light brown area is where it's been eroded. Probably a good part, maybe a half of it has been eroded. Especially you notice it around Denver area where you go east in eastern Colorado, you find it, but it should exist in the Denver area, but just been eroded from that area, close to the Rocky Mountains, applying probably hundreds of meters of erosion in that area. Continuing sedimentary rock evidences of evaporites. Now, evaporites, they believe these evaporated from high saline water. To us, it'd be precipitates or igneous rocks. I haven't made up my mind on that. Some of your viewers may believe in the igneous evaporites, but regardless, I just want to focus in on the size of these evaporites that are dated in what's called the Mycenaean, about 5.5 million years in their time scale. So they're in the late Cenozoic, and they have a volume of 2.5 million cubic kilometers in the Mediterranean Sea. Subbasins are up to 3,500 meters thick. They average 1 kilometer thick, and they're covered by a kilometer of Pliocene sediments. So I ask, how can these evaporites be from some post-flood catastrophe? I can't think of anything that would come close. And as far as carbonates, there's tertiary carbonates. For instance, the Null Arbor Plain, Australia, has 200 square kilometers of late Cenozoic carbonates. How can they be deposited after the flood? And as far as offshore sediments, off the east coast of the U.S., there's 0.4 million cubic kilometers of Cenozoic sediments in the offshore of the eastern U.S. And how can that be post-flood? And here's a distribution of phosphorites with time. Remember, phosphorites are high phosphate sediments that have over 19% phosphate, P2O5 phosphate. You can actually see that there's a good amount of Precambrian phosphates. And, there's no difference. There's no break here at the Precambrian Cambrian boundary, which many creation scientists think is the pre-flood boundary, but these things pass right up through it with no indication of any boundary there at all. One of many reasons why I believe that practically all, if not all, of the Precambrian sedimentary rocks are from the early flood, deposited in deep basins and rifts. But that's getting off the subject. But let's look at the phosphates up in here. Here's the Paleogene, the Neogene. Here's the top of the Cretaceous. This is those who believe that this is the boundary of the flood. You can see phosphorite deposits go right up through it with no big break, indicating to me that all this phosphate deposited in the flood clear up into the Neogene, late Neogene, indicating that the Neogene and the Paleogene, I hope you're not confused by all these names, or the Tertiary is from the flood and not from the post-flood period. How would you form thick phosphorite deposits in the post-flood period? Big problem. As far as ocean sediments, the margin sediments sometimes are very thick. You can see here's a plot from the GlobeSed project. This is up to around 17,000 meters, these red areas, Gulf of Mexico, the Arctic Ocean, right in here, the Bay of Bengal, even in this area of Antarctica. And anyway, they're on the margin, indicating that this is from flood runoff. And about 40% of these would be dated as Cenozoic. And if the Cenozoic is post-flood, how are you going to get those thick sediments along the continental margins? Especially when you realize that there's thick troughs that formed in the Cenozoic off the coast, like right in here. At this scale, it shows that off the east coast of the U.S., you have a trough called the Baltimore Canyon that's 15,000 meters thick. And here's the continental shelf and then the slope right there. Hope you can see my cursor. And you have a similar feature in North Africa. Thick sediments, a good percentage of them Cenozoic. How are they going to form all up and down the east coast after the flood? To me, that's a flood runoff signature. Real easy. I must tell you that when I started on this, I believed certain creation scientists that the boundary was at the KPG. But when I started to examine geology and other features, I found that is very difficult, if not impossible. But let's transition to the second major category, organic evidence. Coal. I'll talk more about coal. Amber. Amber is fossilized tree resin. Oil and natural gas. Large, pure microorganism skeletal layers like diatoms these are all Cenozoic. A lot of this is Cenozoic. You find it in other times of the geological column, but you find a large amount of this in the Cenozoic, which would indicate that to me that it's from the flood. Also, there's a lack of mammals in the Mesozoic that would be buried in the flood according to the late flood position, but millions of them supposedly were buried after the flood. Now, how can that be? So, and then you have huge mammal bone beds in places like agate fossil beds national monument, where you have thousands of mammals crammed into small areas. Also, if you believe that the Cenozoic is post-flood, the Cenozoic has an order of the fossils where they come about or evolve to them, and then they live for a certain time, then they die. They have this order. How would you explain such an order if this is a post-flood feature? And they have numerous extinctions of Cenozoic animals. How would that all happen? So let's go into some of this. Let's talk about coal. 12 to 29% of coal is from the Tertiary. Some pure coal seams are 75 meters thick, like in the Powder River Basin of southeast Montana and northeast Wyoming. Not only are they 75 meters thick of almost pure coal, they're 100 kilometers north-south and 25 kilometers east-west. I'm thinking of the Big George coal seam. That's just one of many seams in the thick Powder River sediments that are Cenozoic. Amber, by the way, that comes from terrestrial trees, but it's found in marine sediments and unoxidized. How does it get into a marine environment after the flood? Not only am I going to point out these problems for the post-flood catastrophe model that believes that the flood boundaries at the KPG, but I'm going to provide evidence of how this occurred. Also, I'm going to take it further and just not present these criteria and leave them like that. Number 4 on that list is 15 to 19% of crude oil comes from tertiary sediments. How are you going to form oil after the flood? You need heat, pressure, and so forth. Also, as far as diatomite, there's a late tertiary, the Monterey Formation has diatomite up to 1,000 meters thick. How's that post-flood? To me, these are all flood signatures. And some of the mammoth problems, like I reiterated, very few would be during the flood. Well, post-flood, if you believe that the Cenozoic is post-flood. And some of them are in large graveyards, like 9,000 animals at Agate Fossil Beds National Monument. And mammals appear and disappear in the Cenozoic. And the whales evolved supposedly in the Cenozoic. And if we think that's post-flood time, we have to think of some terrestrial animal that became a whale. All after the flood, if we believe the Cenozoic is post-flood. How can that be? Well, here's the Wyodak coal seam, Wyoming. Pure coal, fairly thick. It's at the surface near Gillette, Wyoming. And they've been mining it for years. In fact, a large percentage of U.S. coal comes from the Powder River Basin. Some of it from this coal seam right here. Before I get into amber, to form coal has to be heated up to maybe 150 degrees centigrade, 200 degrees centigrade, depending on the rank of coal. To do that, you have to bury it or have it deposited in some hot crater, maybe an impact crater. But if we go on the change in temperature with depth, to form bituminous coal, or let's say anthracite, the highest ranked coal, you have to cover it with 6 kilometers of sedimentary rocks and sediments. And if it's at the surface like it is in Pennsylvania, you have to erode that all down 6. So that has to all occur after the flood in some places, like Powder River Basin. Bituminous coal probably only needs 3 to 4 kilometers of sediment on top. So if that occurred after the flood, you got to gather all these trees into one spot with no other sediments in there. And from some of the trees that we know, polystrate trees in coal mines, some of them are 2 meters wide. In other words, this would have to occur well after the flood. Gather it together, cover it by 3,000, 4,000 meters of sediment. And then since it's at the surface in a lot of places in the Powder River Basin, you have to erode 4,000 meters, all after the flood. And how is that going to happen after the flood? I believe strongly that coal indicates that the Tertiary or the Cenozoic is from the flood and not post-flood. Now we transition to amber. Remember, amber is tree resin. How are you going to get tree resin in marine sediments unoxidized? Well, this is how I think it happened. The secular scientists are almost clueless. You have marine creatures, believe it or not, in amber, and you have and a lot of unique fossils in amber. So this is how I think it occurred in the flood. I don't think this is going to occur after the flood at all. Anyway, you have log mats, thick log mats, based on the amount of coal on the earth. We estimate there was 10 times as much vegetation before the flood, trees and plants, as now. And a lot of this would get ripped up, deposited, forming your coal seam, but a lot of it would end up being floating on the floodwaters. And a lot of organisms would end up on these floating logs and vegetation, a lot of them insects. And as you bash these trees together, you're going to ooze the resin. And so insects could get caught in it on the log mass, like this insect. And it appears that you need another flow to actually cover up the insect, some with wings spread, like this. And then it falls off and they sink. The amber sinks, the logs fall like this to the bottom, and they collect in the bottom, some with vertical trees, some horizontal, and then they get covered up with more sediments and are turned to amber. A lot of amber is found around coal, by the way. So they formed generally from log mats. Coal, I believe, formed from log mats also during the flood. So this is how I think amber formed, but I can't understand how that could possibly occur after the flood. So I think this is another organic feature that indicates the post-flood boundaries in the late Cenozoic. Anyway, I'm not going to emphasize any of the other ones, but I'm going to get into the third major category of evidence, tectonic evidence. This will include not only vertical tectonics, but horizontal plate movements, which I think there was a little, but I lean at this point that impacts caused or the flood, or else they boosted catastrophic plate tectonics. So I mainly believe in vertical tectonics to drain the floodwaters. And then there's three other types of tectonic evidence, which many of the readers or the viewers probably don't know much about. Ophiolites, metamorphic core complexes, ultra high pressure minerals. These all provide evidence. You find these in the Cenozoic. They provide evidence that the post-flood boundaries in the late Cenozoic. So I'll emphasize just one or two of these. Let's take the vertical tectonics. In the Cenozoic, in the Northern Rockies where I live, you have 12,000 to 14,000 meters of differential vertical tectonics in the Cenozoic. Where the mountains rose, the valleys sank down. The valleys, as they sank, carried sedimentary rocks down with them while they got washed off in a lot of these mountains that it rose. And then continuing to fill up some of these basins. But the differential vertical tectonics, 12,000 to 14,000 meters. Also the Himalayas, which are rose in the Cenozoic from the floodwaters. Psalm 104:8. Mountains rose, the valley sank down. That's how you drain the floodwaters. Floodwaters don't have to cover Mount Everest or the Himalayas at all. So these tectonic examples indicate they're from the Cenozoic. How could they possibly occur after the flood? And not only did you have the differential vertical tectonics, you had a huge amount of erosion over many of the mountains, like up in the Northern Rockies here, where you have flat planation surfaces from the great unconformity, the tops of some of the mountains, like the Wind River Mountains, portions of the Bighorn Mountains, Mount Moran and the Teton Mountains, and the Beartooth Mountains in north central Wyoming and south central Montana, exposing the great unconformity at high altitudes where most of the sedimentary rocks were washed off. How would they wash off in the Cenozoic? Why would they raise up that much compared to the upper crust in the adjacent valleys? So, ophelites, these are supposed to be ocean crust and upper mantle rocks. And they're thrust up on continental crust. And some of these occur in the Cenozoic. How can that happen in the Cenozoic? By the way, I believe the secular geologists overuse this term ophelites. And a lot of claimed ophelites aren't really ophelites. They might be mantle rocks, but they're probably not true ophelites. So I think the word's getting overused. As far as ultra high pressure minerals, UHPM, there's over 40 locations of these. A lot of them are in mountainous areas, indicate, and these are supposedly in continental rocks. Ultra high pressure minerals include coesite, stishovite, and sometimes you have diamonds in there. And to form all this, you have to sink the continental rocks around 200 kilometers, and some places times 400 kilometers, and then it has to rapidly rise to the surface. Well, many of these locations are in Cenozoic rocks. So how is that going to happen after the flood? Even during the flood, postulate that it formed at subduction zones, but I find that a bit difficult to believe. I think I think secular scientists have extreme difficulties explaining these. And by the way, these were a great surprise when they discovered them 40 years ago, approximately. And but then I want to add, how would they form after the flood? Those that are Cenozoic. And here's a little schematic of how of the great vertical tectonics, like the Uinta Mountains. They're up to 14,000 feet, and the adjacent basins are below sea level, and the difference is about 12 to 14,000 meters. So here's how I think the Uinta Mountains formed in the floodwaters. You have, in this case, it's not the upper crustal granites and gneisses, but in this case, it's the Uinta group quartzite. I think it's a Precambrian rock formed in a basin or rift. Anyway, formations formed on that. And then as the mountains rose, the valley sank down in the Cenozoic. This all happens in the Cenozoic. It planed off part of those sediments, forming a planation surface you can find in some spots on top of the Uinta Mountains today. And then they continued up. And by the way, these, I'm looking towards the east. Or am I? Well, eastern or west. Anyway, I believe that once this breached the surface of the floodwaters, then the current started to flow around them and form what's called pediments, gravel cap planation surfaces at the foots of mountains. That's what these represent right in here. And a lot of that continued to erode as it all uplifted. Like in the north right in here, it used to be continuous and it became eroded. This is the general pattern of the Uinta Mountains today. I'll talk more about pediments when I talk in the geomorphology section. Which I'm going to start now. Okay. We have 9 evidences in geomorphology. And this is where I first became suspicious of the KPG flood post-flood boundary, when I realized how much Cenozoic history there is from geomorphology. As I've already touched on, the first one is we can show approximately 1,900 meters of continental erosion mostly in the Cenozoic. How is that going to happen after the flood? In some places, the Cenozoic erosion is up to 6 kilometers in the central Appalachian Mountains, for instance. So you have rapid continental erosion, approximately 1,900 meters. I and two other creation researchers, John Reed and Peter Kleberg, have calculated from flood runoff. Then we have erosional escarpments. A lot of these are on the coast, all around southern Africa, but approximately 3,500 kilometers long. They're kind of like cliffs or steep slopes. How are they going to form after the flood? I'm going to show a figure of where they are in Africa, but you have them in eastern Brazil, western peninsular India, and other places. Also planation surfaces, which are flat surfaces that are carved on hard rock. And then erosional remnants are a lot of times left in the Cenozoic. Floods leave erosional remnants. They don't erode everything straight, flat. Also, the long distance transport of hard rocks occurred predominantly in the mid to late Cenozoic. Also, deep canyons and valleys formed in the Cenozoic. Pediments, which I will talk a little more about. I've already touched on it a bit. Water and wind gaps and submarine canyons. All these are Cenozoic features formed during the 1,900 meters of continental erosion, depositing this material mainly along the continental shelf and slope of the continents. So let's amplify a few of these. First of all, let's talk about the biblical geological model. In the flooding stage, that's where your thick sediments over huge areas with your fossils were deposited. And at the peak of the flood, the water started to retreat. As the continents rose, the ocean basins sank, as well as mountains rising and adjacent valleys sinking. This is called the retreating stage in Taz Walker's biblical geologic model. This is straight from the flood. Doesn't matter what the geological column says, even though some of it corresponds pretty good and some of it doesn't. Anyway, you have during the retreating stage, you can divide it up into two phases. Number 4 is wide currents, maybe 2,000 kilometers wide, 5 kilometers deep, moving across the world. And then as more mountains and plateaus stick up above the floodwaters, the water is forced to go around to channelize, and that forms phase 5, which should generally be superimposed upon phase 4. I call phase 4 sheet flood erosion, and with the wide currents, because if you look down current, you have the consistency of a sheet spread out, very thin and wide. And then the phase 5 would be the channelized, where it's forced to channelize, and that forms certain features in geomorphology distinct from the sheet flow phase. So I will amplify some of these from phases 4 and 5, the breakup of the retreating stage. And here's, we calculated just recently that the amount of erosion, like I said, is 1,900 meters. So that means at the peak of the flood, that 1,900 meters existed on top of the continents on the average. This is an average for the whole continental areas. And we have to add that to what's left, which we're not certain how much is left. There's estimates, but there's problems with those estimates. Anyway, all this was eroded, and this is the present continental surface we see today after the erosion after day 150 during the recessive stage. That's the big picture in a block diagram. And of course, that erosion ended up being deposited along the edges of the continents, like I showed you in this scheme earlier. Okay, great erosion. This is practically all during the Cenozoic, or I better not say practically all. Maybe about 50% of this continental erosion would be in the Cenozoic. There's some dating issues with it in the secular time scale. Okay, here's the great escarpment around Africa. It's discontinuous in places. It's about 3,500 kilometers long all the way around it. In Namibia, I spelled it wrong. It's about 1,000 meters high. The Drakensberg in South Africa is 3,000 meters, generally a cliff. So how would this cliff, these are Cenozoic features, how would they form after the flood, these great coastal escarpments? That's the issue. To me, it's a flood feature. And I would lean this is how you formed not only the continental margin sediments, a lot of it in the Cenozoic, but the great escarpment. You had massive erosion. This is focused in on Southeast Africa, by the way. And so you erode, the land's coming up, the water's eroding the top and carrying the debris down, forming the continental margin sediments like this. And with time, it forms kind of a waterfall feature and backs up this great escarpment from near the coast up like this, back like this. And the planation surface is called the African surface. That's how, and the thick eroded sediments are from the continental margin. A lot of this activity occurred during the Cenozoic. Planation surface. Here is one in north central Montana. You can see that it's about flat as a pancake. Over to the left, they actually had an airport built because it was so flat. And there's a giant planation surface at the top of Grand Canyon, as you'll see right in here in this slide I've shown already. And that represents erosion of thousands of feet of sedimentary rocks and strata, depending on how thick the strata was. But if we go by the Grand Staircase, it'd be 10 to 12,000 feet. But this Grand Canyon, the east-west, is kind of a bulge. And so on the bulge, it might have been thinner sediments. So we don't know whether it was 10 to 12,000 feet of erosion, but regardless, it's a lot of erosion, thousands of feet of erosion. We do have some erosional remnants that indicate that the thickness of the lower strata you see in the Grand Case is about 1,000 feet thick. So indicating that there probably wasn't much thinning of these sediments from the Grand Staircase over the Grand Canyon area. But regardless, it formed a planation surface that you can see from the large scale. Here it is. We're seeing in here, the Grand Canyon's in this gap in here. That's the north rim in the distance. And this is the south rim. And the planation surface just slopes to the south. That's why when the Grand Canyon was cut at intermediate altitudes of this Kaibab upwarp, that cut a section here. So this is actually a continuous planation surface from the north rim to the south rim. And it's because it slopes down, it's been cut at intermediate levels to form Grand Canyon. Planation surfaces aren't forming today except maybe where a river floods, moves out of its bank and erodes the strata. But that's only very local. And if we wanted to apply that example for these large planation surfaces, we're going to have to talk about with huge erosion that's not occurring today, but is typical of what's expected in the flood. Many of these planation surfaces are Cenozoic, which means you have to do all this planing after the flood. Well, how can that happen? Another reason why I believe that the flood post-flood boundary is in the late Cenozoic. These planation surfaces were formed by flood runoff. They're in the flood, not after the flood. This is what we expect by uniformitarianism, is that tilted sedimentary rocks, which a lot of times sedimentary rocks are tilted. This is what we should expect everywhere, but a lot of times we see these planation surfaces with rounded rocks, the rounded rocks from water that are capping the top of many, if not most, planation surfaces. And the third geomorphological evidence is that floods leave erosional remnants. They don't erode everything out. Like, for instance, this is a Steamboat Rock in the Upper Grand Coulee, about a square mile, 900 feet tall, of basalt layer flows of the Columbia River basalt that was carved out around it in the Lake Missoula flood. All of it was carved from that flood, leaving this as an erosional remnant. There's a number of erosional remnants from the Lake Missoula flood. We see those with flash floods. They leave erosional remnants. But you know that there's lots of erosional remnants, thousands of them on the surface of the earth. A lot of them are above planation surfaces. And they give them names like monadnocks, Inselbergs, Bornhards. And my favorite erosional remnants is Devil's Tower. Now, this is considered by most geologists as the throat of a volcano or a conduit where the lava was coming up. And you got to think of the volcano once being up in where the air is right now, up in this area. Devil's Tower in northeast Wyoming is about 1,200 feet tall. And so not only did the volcano get eroded, but it eroded all the material around this erosional remnant for some reason. Maybe the current slowed down there, maybe a little harder rock. There's reasons, but one thing you could say, this had to happen rapidly, because if it's slow erosion over millions of years, this thing would be a pile of rubble, because this thing is loaded with cracks, and freeze-thaw erosion should destroy that in probably 50,000 years would be my educated guess on it. But they're standing tall, hardly generally about the similar height, width. And secular scientists give it millions of years for all this erosion. And they say probably about 3,000 feet, way up in here were the sediments. And the volcano was above that. Volcano got eroded 3,000 meters, leaving this as an erosional remnant. Now, the point of that for this talk is that this erosional remnant formed during the Cenozoic. So all that erosion had to occur in the Cenozoic, leaving Devil's Tower as an erosional remnant in the Cenozoic. Practically all erosional remnants on the earth are from the Cenozoic time. Now let's go to the fourth, and this is a resistant rock spread long distances. Now in my area, the resistant rocks are quartzites. The other rocks are softer and they get pulverized. And so here's you find these quartzites as thick layers in the Western Rockies, extreme Western Montana, northern central Idaho, extreme Northeast Washington, and up in Canada. That's where it was eroded from. And I found them clear into central Saskatchewan, western North Dakota, but they're supposed to be out in southwest Manitoba. We're talking about quartzite rocks from their source, transported 800 miles far out into the plains by the hundreds of billions of these rounded, and they're rounded by the action of water. Not only are they rounded by the action of water, they have semicircular cracks. Quartzite's a hard rock with a Mohs hardness of 7. Pretty hard rock. How are you going to form a percussion mark on this? Well, secular scientists say it's from torrential flow. But I don't know of any flow today where they claim that percussion marks are forming on hard rocks. I might be going kind of quickly through this to some, but these represent other talks I have explaining all these in a lot more detail. But I'm just focusing in on that these features occurred during the Cenozoic and are more indicative of a flood signature and not post-flood. The main outcrops are west of the Continental Divide, and they're found east. How would that occur after the flood, by the way? And then, as more mountains and plateaus rose above the floodwaters, the current would split and channelize. And some of the currents would go back to the Pacific Ocean, and I find quartzites clear to the Pacific Ocean and up on the tops of mountains, the Blue Mountains in this region of Oregon, the northeast Oregon, Wallowa Mountains, the Teton Mountains down in here, and the Gravelly Range. I find quartzites, rounded quartzites, big ones, on the tops of these mountains, indicating that the quartzites were spread and the mountains rose up and carried them up, showing that not all mountain ranges rose at the same time, but some rose earlier in the flood runoff and some later. Let's take a look at some of these. Now, this is a quartzite from the top of the Gravelly Mountains in southwest Montana. You can see the texture of quartzite. It's a metamorphic sandstone. It's been heated up to around 300, 400, 500 degrees centigrade. I'm not quite sure. But anyway, it's been the particles of the sandstone were practically all quartz. This would be considered a quartz arenite. And they recrystallize with the heat and fill up the pores and become very dense, and it's hard. And you can see that there are hundreds of percussion marks on this quartzite boulder found at the top of the Gravelly Mountains. There's another quartzite found east of Lookout Mountain in the Wallowa Mountains, 8,200 feet. We estimate that weighs 440 pounds, well-rounded by water action, smooth by water action. Nearest source is about 60 miles away in central Idaho, across current Hell's Canyon, indicating that the quartzite passed by. Hell's Canyon formed after the quartzite passed by. By the way, the currents were so fast that you find gold in these finer grained sediments. That's the pulverized rocks that occur with the quartzite rocks, layered quartzites in the mountains. It was pulverized, and as it spread, the gold went with it and didn't end up at the bottom of the flood current. In fact, they had a gold mine operating on the top of the Wallowa Mountains. They were placer mining this gravel here, not this spot, but somewhere other place, and finding gold until they became a wilderness area and they had to shut down the gold mine. Can you imagine a placer gold mine sending water through a sluice box at the top of the Wallowa Mountains? Incredible. Anyway, Cenozoic again. This, to me, is a flood signature. Just recently, on the Creation Ministries International Egypt tour, I found a similar feature on the Giza Plateau of Egypt. This isn't quartzite. This is chert. You can tell by the conchoidal fractures. But look at all the percussion marks, indicating torrential flow. The big picture is that Tertiary limestone was deposited over this area of Egypt. And then it channelized going north to south and cut a valley 10 to 20 or more kilometers wide, several hundred meters deep. And it channelized, moving at high speed. And there's a lot of chert in that tertiary carbonate. It's as nodules or layers. And as it got all eroded and pulverized in this valley, the chert is harder and pulverized the carbonate, but these hard rocks, which are found in a lot of places in Cairo, in this place, and they were left as erosion on this plateau, the Giza Plateau, where the three main pyramids are found south of Cairo. So you find hard rocks transported long distances with percussion marks, things that aren't happening today. Can they happen after the flood and some catastrophe? Boy, I'm hard pressed to think of any catastrophe that would spread these rocks so far, especially the quartzites, 800 miles across the Continental Divide. by the hundreds of billions out there on the planation surfaces east of the divide. Okay, now we're going to transition into more channelized flow features. Here's a pediment. Pediments are found all through the Rocky Mountains. This is in southwest Montana near where I live. This is the Ruby Valley. Here's a pediment right here. And you can see the sedimentary rocks dipping to the east. I'm looking straight north, maybe 2 to 5 degrees. And the pediment goes against these rocks, which are usually hard and soft rocks together. That's a common feature of sedimentary rocks. Sheared it off the same and left about, you can't see it here, but 15 feet of rounded rocks, most of which are quartzite rocks that don't outcrop in the area, but had to be transported from far away. And here is the capping of rounded rocks. Like I said, most of these are quartzite rocks spread from extreme southwest Montana or central Idaho, but they don't outcrop in the nearby mountains, indicating the pediments were formed by down valley flow. The whole valley filled up with water flowing at high speeds towards the current oceans. And of course, the origin of these pediments are unknown. They're not forming today, by the way. So how would they form after the flood and some catastrophe? I don't think they can. People that doubt me need to demonstrate that I'm wrong. And so far, nobody that believes in the KPG has really delved into these in any depth or published anything. I can't find anything. Anyway, here's a little quote. You find a lot of pediments in deserts because deserts are areas today that haven't been tremendously eroded. A lot of pediments have been eroded out. And they realize that they say pediments have long been a subject of geomorphological scrutiny. Yeah, they've known about these for well over 100 years. What's the result of this? Unfortunately, the net results of this long history of study is not altogether clear or cogent and has not produced a clear understanding of the processes responsible for pediment development. You know, you see statements like that last sentence there in geology. Being a retired weather forecaster, I became a master of weasel words. It may rain today or it may not, things like this. But these are weasel words for we haven't got a clue how pediments form. They like to kind of cloak it into, we're close to maybe doing it. Give us more money in our grants and maybe we'll figure it out. Anyway, they've known about pediments for well over 100 years and they haven't figured it out yet. But they can form easily in the flood. Remember, I'm not just going to criticize uniformitarianism and post-flood catastrophism, but I'm going to say how I believe they formed in the flood. Okay, you had currents going parallel with ridges, for instance, and ridges will crack. And as they crack, the water will especially erode the cracked areas, and it'll end up like that. And as the floodwaters channelize, they accelerate, and they carve the edges of the valley or the edges of the mountains to flat surfaces called pediments, a planation surface at the foot of the mountain. That's the definition of a pediment, as you can see here. And as it's all over with, you're left with the valley and the flat surfaces at the edges of the valley. And the present river is cut a little deeper than the pediments usually. Pediments are found in many valleys in southwest Montana and actually the Rocky Mountains of western U.S. a lot. The biggest pediments are in Arizona, by the way. I think one pediment is 600 square miles. Huge pediments. Also, water gaps. I'm not going to talk about wind gaps, but you have a lot of water and wind gaps that formed in the Cenozoic. And here's my favorite near Cody, Wyoming. I'm looking east towards Yellowstone Park up in here. And here's Cody. You can't really see it well. And here's a water gap here where it cut through 2,500 feet of the mountains. It's a granite uplift with the sedimentary rocks. You can see them banked up against, you can't see the granite, but you can see the layering of the sedimentary rocks. And the Shoshone River starts in southeast Yellowstone. And it could easily, when it came to these Rattlesnake Mountains, just gone around it this way out in the Cody. Instead, it just continues east and cuts a water gap 600 meters or 2,500 feet thick. How'd that happen? Well, this is what you see when you get on the other side of the water gap. There's a road through the water gap. There's a dam there. And this is the low area on the other side where the river should have easily gone around the Rattlesnake Mountain, but ends up going right through it. Now, rivers don't do that, but you can do this easily in the flood, as I will show you. For instance, as the waters are draining during the recessive stage and or the land is coming up or both, you have currents going perpendicular to ridges. And since ridges aren't totally even, the current will tend to accelerate through the low areas like this right in here or this area here. And with time, all that water is forced to go through two areas, this area here and this area. And as it continues, it erodes these areas, in this case, very deep, in this case, not deep enough. And for some reason, this current gives up, leaving this water gap, potential water gap, hanging as a wind gap. Only wind goes through it. And all goes through here, digging that so deep that the water passes through the mountain ridge as a water gap. So it's fairly easy to understand how water and wind gaps can form by draining floodwaters in the flood. And there are thousands of water and wind gaps across the earth. Some of them are very deep. Some are miles deep, like in the south of the Tibetan Plateau in the Himalayas. And we have some pretty impressive water gaps in the western U.S. The Appalachians have 1,700 water gaps and a lot of wind gaps that cut through, where the water cuts through the ridge when it could have easily gone around if it was slow process erosion over millions of years. The point of this is that all these water gaps and wind gaps formed in the Cenozoic. Now, how are they going to form after the flood? This is typical of a flood feature, and it's easy to understand how this can happen. So I'm going to get to the last section, which I don't really have too many pictures of, climate and miscellaneous evidence. For instance, you find warm climate fossils in the Cenozoic at the mid and high latitudes. I've delved into this. In fact, one of the preliminary questions asked about the new warm climate fossils, if they found DNA from organisms in northern Greenland. And I just heard about this, but I believe in looking at the original papers before I determine whether this is from the flood, because there's a lot of warm climate fossils in Alaska, Siberia, Antarctica, from the flood. But during the Ice Age, the water was warm at high latitudes. The Arctic Ocean was warm, and so therefore the warm onshore flow, you'd have warmer temperatures early in the Ice Age, close to the ocean, close to the Arctic Ocean, for instance, on the west coasts of continents. So these fossils can be from animals rounding the Bering Land Bridge and staying in the north near the Arctic Ocean and spreading to as far as northern Greenland. So I haven't determined that. In fact, I'll probably write a little article on it, a perspective article for Creation Ministries International for their journal Creation. So now, if you have these warm climate fossils at the mid and high latitudes, how can they, except for the Ice Age, this is a fairly strong big signature that these fossils are from the flood, because they're buried by sediments, for instance. Like the ones in Greenland, I think, are on the surface, as you'd expect in a post-flood scenario. I actually kind of lean towards a post-flood scenario for that, but there's a lot of buried fossils, mid-high latitudes that are from the Cenozoic that show a very warm climate, sometimes subtropical, and animals like lemurs on Axel Heiberg Island and the Queen Elizabeth Island. So you have a lot of that. And I think you can't have that after the flood, except in maybe local areas on the surface. Here's one that I think is especially important. We have a lot of Cenozoic volcanism, forming stratovolcanoes, huge layers of ignimbrites, like in Mexico, that would indicate that if all this was going off after the flood, you'd have so much volcanic debris and aerosols that you'd cause what's called volcanic winter. You'd cool off the climate so bad that a lot of organisms would die. But this could be easily the trigger, could be the trigger of the ice age after the flood. I believe volcanic winter, if it was all the Cenozoic was post-flood, you'd have volcanic winter that would have be a big problem. A lot of organisms would die coming off the arc. Also, you had impact craters like the Chicxulub impact in the Yucatan Peninsula at the KPG boundary approximately. And this impact is believed to be able to cool the climate 20 degrees centigrade or more for maybe up to 10 years because of that impact, which I believe is during the flood. But the debris and the aerosols would last into the early post-flood period. So you'd have impact winter early in the Cenozoic. And if that's a post-flood, that'd be a serious problem for all organisms leaving the arc. Of course, you had a lot of accelerated radiometric decay in the Cenozoic. So I would place that a bit better it's in the flood than after the flood, because that would probably kill all organisms. Also, the Cenozoic geology of the Middle East has been emphasized by Tim Clary. You have carbonates right in the around Mount Ararat. They're tertiary. So how can you have that tertiary carbonates formed in an ocean all around Mount Ararat after the flood? And then you have this Whopper sand in the Gulf of Mexico, a thick sandstone formation way out in the Gulf of Mexico. It takes a lot to move that sand way out there. And this is a Cenozoic sand. So the Whopper sand indicates that the Cenozoic is, the Whopper sand had to occur during the flood. Anyway, that is the 33, 35 indications that when you add them all up, the flood post-flood boundary is in the late Cenozoic. Now, I admit there's some difficult locations, and these are three of them right here. I'll talk briefly about the Australian marsupials and the mammals of the central and the southern high plains of the U.S. Certain creation geologists and biologists have challenged me on these issues. So I've looked at them, mainly the last two. And I discovered with the marsupials that when you look at these locations and the history, that when they first found these marsupials in the sediments, a lot of them they're right on the surface, a lot of them, and are in thin sediments, found in caves sometimes, or eroded caves. They were, first of all, dated as Pleistocene, which is a good amount of the Pleistocene, I believe, is post-flood. So that's reasonable. I would go along with that. But as they examined the bones, they discovered what they call primitive features. Said, well, they have to be older in the stage of evolution. So they kept pushing back the dates of these marsupials, Pliocene, Miocene, and clear to the late Oligocene is where a lot of them are. based on what they call the stage of evolution. There was very few radiometric dates to anchor any time scale in these locations. It was all done on the fossils and the state of the fossils, whether they had primitive or so-called primitive and advanced features, all the stage of evolution. So that's why they pushed those back. I believe they're post-flood. And they pushed them back into the late Oligocene, which technically is early flood. But yeah, so be it. Let them, fine. That, I believe it's post-flood. It's close to the Miocene, which I consider late flood. But they do this. They'll change this. Like, for instance, they dated the Antarctic ice sheet as late Pliocene and Pleistocene once. But then to fit it into other features, they decide to increase the age 10 times to the point where the Antarctic ice sheet supposedly began in the early Cenozoic. And it's obviously a post-flood ice sheet. So they did this, but I would consider that post-flood. Those are the only two examples of what I call the early Cenozoic that I believe are post-flood, and not from the flood. But anyway, I actually gave a hypothesis on how to explain these marsupials, which I believe are post-flood, which is beyond the scope of this talk. It's in the Journal of Creation in a 4-part article on the subject. The fourth part, which was just published in the latest Journal of Creation, is about these mammals of central and the southern high plains, where it's said, well, in other places in the U.S., Florida, where it says that tertiary mammals and Pleistocene mammals are fairly similar, indicating that the tertiary mammals are post-flood, as long as same as the ones in the Quaternary. Anyway, these are difficult arguments to talk about, but let me kind of summarize what I'm saying quickly. The mammal fossil challenge goes like this. They claim mammal fossils are too similar in the Tertiary and the Pleistocene of North America for the Tertiary to be from the flood, and the Pleistocene from the post-flood period. That's what they're saying. I've looked at this, and they say there's no pronounced break in fossils from the Tertiary up to the Pleistocene in North America. And you find many of these mammals on the southern and central high plains. So getting back to the geological column to kind of the Pleistocene is most of the Quaternary, by the way. So they're saying if the Tertiary is from the flood, why are the mammal fossils so similar to those in the Pleistocene, which are post-flood? Well, that's the upshot of this. So they say, therefore, that can't be. They're too similar. So the boundary has to be right in here between the Cretaceous and the Tertiary, or the KT boundary, or the KPG boundary. The name has changed in the last few years. That's the argument. So I looked at these fossils, and this is the critics have produced some straw man arguments, but I'll get into that. But first of all, they're saying that I assume the flood post-flood boundaries at the Tertiary Pleistocene boundary. But I don't. I think it is there now and then, but it could be down in the Pliocene or even the Miocene, and sometimes in the late Oligocene. So I don't take these precise designations of the geological column as biblical Earth history. And they also have claimed that I believe that animals had to head for the ark from their current continents. If the marsupials from Australia have to go to the Ark and then back to Australia. Or the animals in North America had to go around the Bering Land Bridge to the Ark, assuming it's somewhere in Asia, or we don't really know where the Ark started, and then come back across the Bering Land Bridge to where they find them today, in my scheme. And they say some of the North American mammals from the Pleistocene, the genera, have to be unique in the Tertiary and the Pleistocene before. So unique genera that lived during the Ice Age or even today are too similar to those that are from the pre-flood period, which would be the Tertiary. From my view, this is what they think I believe. But a lot of these are straw man arguments, because the animals don't need to come from the continents you find them today. They could have come from near where the Ark was built. So that's the problem. That's a straw man argument. And also, I don't believe that the boundary is at the Tertiary Pleistocene boundary, but in general, in that broad scale, the late Cenozoic. So my explanations for the fossil challenges are, some of these were straw man arguments. And the post-flood boundary can be in the Miocene, Pliocene, or Pleistocene, or even the late Oligocene for the marsupials, assuming the geological column for sake of discussion. And animals did not have to leave for the Ark from their present continents. But I do agree with this, that the post-flood animals, those from the Ice Age and that live today, had to spread globally from the Ark. That I do agree with. So, and I've gone into these, and I'm just going to simply sum up some of what I've said in the Journal of Creation in a 4-part article. Like I've already mentioned, Australian marsupials were once dated as Pleistocene. That's great, post-flood, I agree with that. And the primitive features pushed them back to the late Oligocene, assuming a stage of evolution. They have assumed evolution to push them back to the late Oligocene, you see. And I've concluded they're post-flood. But there's a global distribution of marsupials on all continents in the early Tertiary, so I believe those are from the flood. And I believe that many of the late Cenozoic ones in South America are from the flood also, but that's beside the point here. Then I looked at North America. I discovered, using the paleontological paleobiology database, which is a database of all the fossils and where they're located and their ages. And that's what this certain creation science critic of the flood post-flood boundary challenged me on the fossils from that database. So I went back to all that was published, that he published on for those genera of animals and even families. And I discovered that all the genera on North America are also found on other continents for both the Tertiary and the Pleistocene. So they're not unique. They have to be unique only to North America, but they're not. They're found on other continents. Now, some are close to being unique, so it's not exactly a slam dunk for my position. I think more research is needed in all this, but I found that a lot of them were not unique. Then I discovered that 12% of the genera were deleted from North America in the paleobiology database. In other words, they claimed a certain animal, a genera with a species name, lived, but then suddenly they disappeared. They were deleted. So I found that quite strange. In fact, that told me what the quality of this database. So I'm saying that the same genera likely can occur both pre-flood and post-flood. But the genera might have differences between the two. Excuse me. And many tertiary mammals from North America are not found today or in the Ice Age. So this is recently published research. And the Ogallala Formation, which is considered post-flood by some creation scientists, have some really strange animals that don't occur during the ice. I believe this is a tertiary. This is a dated tertiary or late Cenozoic. But you find all kinds of strange other animals that you don't find in the Ice Age. Oreodonts, Chelicothere, shovel-tusked elephants. This is where they have the lower tusks are like plates or shovels, as they call them, as well as the upper tusks. These are found in the Cenozoic, but you never see them, as far as I know, in Ice Age sediments. You don't see them in any of that Siberian permafrost. Three-toed horses you don't see in Ice Age sediments. Also in the Ogallala Formation, you have a camel the size of a gazelle, 60 centimeters tall. Then you have another camel that's the size of a giraffe. A four-pronged pronghorn, which some consider an antelope, and but four-horned, you don't see this in the Ice Age. And then a saber-toothed deer. Ever hear of a saber-toothed deer in the Ice Age? To me, these are indications that those sediments are from the flood. There are some, though, that are similar from the Ogallala Formation that you find in Ice Age sediments, like the saber-toothed tiger. But I haven't analyzed that in depth, but I'm thinking that you probably have different species of these between the flood and the post-flood. But anyway, some are similar, very similar, which I believe are flood and are post-flood. But to find others that aren't in Ice Age mammals and are more appropriate to put in the flood. And now I'm about ready to end. I know this is rather a long talk, and we started late because I couldn't get my computer going. Mostly operator error. I've generated some opinions over 50 years of creation research on fossil data, and I might step on some toes of those that are paleontologists, creation paleontologists, or others that know a fair amount about it. But I've read a decent amount of this to come to these opinions. Fossils are mostly scraps of jaws and teeth. So it's kind of hard to fit that into any family, or a lot of times families you could fit them into, but genera and species, So it's difficult to divide fossils into genera and species in the first place. And I still find too much subjectivity. And from the paleontology database, in the last 10 years since the critic published, I found 5% new genera and families added to it and 12% taken away. That to me has shown there's a lot of subjectivity in this, and as more information comes up, you got to either add a new genera or species or even family, and then you got to subtract some. So I'm thinking there's just too much subjectivity in all this, which makes me doubt biostratigraphic correlations, especially if they use to date the strata. Quick summary. 35 criteria point to a flood post-flood boundary in the late Cenozoic. It's hard to imagine very many of these 35 occurring in a post-flood catastrophe after the flood. Fossil data said to contradict the late Cenozoic boundary, but I have found that not so. The boundary is in the late Cenozoic, assuming the geological column for sake of discussion. And that's the end, and time for questions.
Mike, I appreciate that presentation. Definitely not too long for me. It's such an important discussion. I appreciate how thorough you are in addressing each of the challenges, but then providing your own lines of reasoning for the flood boundary that you're defending. One, I could speak on this for the next 2 hours, but I'll just mention one that I think is undeniable evidence for a higher flood boundary, and that would be the pure coal seams that you described in your presentation that are 75 meters thick. And you mentioned a ton of in my opinion undeniable lines of evidence for why the late Cenozoic has to be the flood boundary rather than the KT boundary. But my main question to start off with, and I'll say we've got a lot of great questions in the live chat. We've had a great audience, lots of well-informed individuals sending in their questions. So, and my own personal questions, Mike, you basically answered them comprehensively in the presentation. So I really appreciate that. This is a presentation that definitely needs to be passed around. And so the question I'll ask is, have the 32 geological evidences for a late Cenozoic flood / post-flood boundary that you've presented been engaged by critics of your flood boundary model specifically?
Well, I published 32, but I forgot one. That's erosional remnants. So 33.
33.
And Tim Clary has added 2 more. In general, Tim Clary and I agree pretty much on this topic. No, the critics have not engaged in it. And I'm quite disappointed. It's not scholarly to not engage, but I've engaged in theirs, and I've presented 4 papers on this very subject in the journal Creation. And I can do other papers because I can see other areas that need fine-tuning research. So yeah, they have not engaged either in print or talked to me about it. But I live in the outback of the U.S. in Montana, so I don't really come in contact with any of them for them to engage me personally, but they can always engage me by email.
Right. Well, and that's what I really appreciate about your presentation, Mike, is you went over all the number of lines of evidence that would suggest a higher flood boundary, but you also ended it by addressing very thoroughly, in my opinion, the major objections that have been advanced towards you, like the patterns that we see in specific mammal groups and the marsupials and the fossil record. And I completely agree with you in terms of the fossil data. It's very low confidence and very low quality science, rather than the geology that you're looking to. So do you find that a lot of the KT boundary proponents that are paleontologists, are they putting the fossil record data before the geologic data, would you say?
Indeed they are. I think they take the fossils way too seriously and the goodness of all this stuff. And, I'm not a paleontologist and I don't have their wide knowledge, but I read a lot, and those conclusions, from my opinion, are from a lot of reading of the state of the fossils, and just my study of the North American mammal fossils, where they added 5% and took out 12%. That to me is evidence that there's a lot of subjectivity in all this, and you'd expect that because what are we dealing with? Bones and teeth. I mean, jaws and teeth.
Right.
Mostly.
Jaws, teeth, bone fragments. And a point that I like to make in terms of fossil record data, especially versus, real-time data like in genetics and biology, is without the ability to do breeding tests or even have the DNA data of these fossil organisms, it's very difficult to determine confidently any kind of relationship in the fossil record. How do we determine what's the result of homology? How do we determine what's the result of convergent evolution? And so I don't necessarily believe that the fossil data is what we should look to first. And I think that's why your criteria is so important, Mike, in terms of determining the flood boundary.
I agree, because fossils are the state that I summarized. I don't think we can use that as the main criterion. I think that'd be a secondary criterion. Find out the age of the position of the strata, flood or post-flood, and then deal with the fossils after that. That's my approach to it. I just don't. Besides that, that's what fossils are one criterion. Well, Clary and I have 35.
Right. Now, for somebody who holds to a KT boundary model in terms of the flood, would they then have to invoke some pretty novel changes or rapid changes in terms of the organisms that come off of the ark? For example, in terms of whale evolution, I know the series of whales that you see, or even horse evolution.
Yeah.
Because if we put it higher, then just with pre-existing diversity and environmental related adaptive changes, we can explain the species and variations we see today. But if you put the boundary closer to the KT boundary, well, now you have some massive changes to explain. Is that right, Mike?
Yes, massive changes, massive production of species, genera, families, and maybe orders, and then they go extinct at various time slots. All that has to be explained as post-flood, and that's one of my mammal criterion there. So yeah, I see that as a big problem. I rank these in the publications I've done. In fact, I talk about them on my website in an ebook, the parts of it which were published in the Journal of Creation over the last 10 years or so. I marked whether those who believe in post-flood catastrophes, the Cenozoic being post-flood, whether they can explain them or not. And most of them I thought were strong evidence that they could not explain and would be fatal to their position. And some were weaker than others. And so I rated them that way, weak to moderate to strong, whether I thought that they can have a good post-flood explanation or not. But that's a subjective classification I gave. But I'd say most of them were strong evidences that I believe are fatal to the KPG boundary. For instance, the coal. The coal is really
right.
And there's a lot of late Cenozoic coal seams in the world, by the way. I forgot to mention that.
Well, these 75-meter thick coal seams that we find, on the planet in certain areas was a very convincing line of evidence for me. I've looked into this as objectively as I can. And correct me if I'm wrong, I've done a lot of reading in the literature, but it seems like heat and pressure, which we know would take place during the flood, we'd have a lot of heat and pressure, can rapidly form coal, oil. And so it makes sense that the massive amounts of coal that we find would be produced directly in the flood year itself, rather than in post-flood conditions.
Yeah, you deposit the plant material, and then you pile up sediments on top of them. You press it down, it heats up. Maybe some catalysts are needed, like ash, some have said. And then if the coal's at the surface, all that gets eroded off, and that would occur during the recessional stage. That's, to me, a flood signature, that we can explain it by the flood. But after the flood in a catastrophe, very difficult, if not impossible. In a secular point of view, the peat swamp theory has numerous problems.
Well, the massive amounts of energy and heat that oftentimes the critics point to anyways, in the form of what's called the heat problem, could be utilized. The pre-flood world could be the perfect battery to rapidly form all of this coal, natural gas, and oil. So it makes sense that these massive coal seams would best be explained during the flood year itself. I'd wonder, I'll ask you this question, then I'm going to get to some of these audience questions. How would those proponents of a KT flood boundary, how would they respond necessarily to the coal seams in a post-flood world?
I have the foggiest idea how they would do that. I mean, I want to see them try.
Right.
So if anyone's listening to this that believes in the KPG, please try to refute the coal and the other ones. I mean, that's a scholarly approach if you're going to believe in the KPG boundary.
Right. Okay, I completely agree, Mike. This has been an awesome presentation. So here's the first question that comes in. This one comes in from Dr. Joel Duff. Appreciate you being here during this important presentation. He's got a question for you here. I've got it up on screen, Mike, and he's asking, there are mammoths below Mike Oard's boundary. and above it in multiple locations. Is he saying mammoths were the same before and after the flood, as well as 50 other species of elephant?
Okay. How can I get to the questions? I got
Good question.
I get out of my
Yes.
presentation.
Yep. So I'm guessing you probably just see your black slide on your presentation.
Yeah.
If you go down to the bottom of your main computer where all the icons are, if you see
There's no icon. It's a totally black screen.
Oh, you know what? If you press escape on your keyboard, because I think you probably have your presentation in full screen mode. Yeah, there you go. And if you scroll down to any icons you can see, you're probably looking for an Internet Explorer, possibly a Google Chrome tab. As long as you get into the StreamYard.
I wish I could go back, but
Actually,
maybe better leave well enough alone.
Yeah, if you leave it like that, Mike, no worries. I'll put them up on screen, the questions for the audience sake, but I can read them out to you, so no worries at all.
Okay.
Yeah, go ahead.
The question was the mammals. The mammoths.
Mammoths, yeah.
You could say the same thing for a lot of organisms where you find the families or orders in the flood and the post-flood period. There's a lot of different elephants as fossils, mammoths, and they date mammoths 4 million years at the most, I think, and they have a whole scenario where they came out of Africa and evolved in Eurasia and then came late across the Bering Land Bridge, so forth. I think some of these claimed mammoths that would be from the flood, whether they're dated Pliocene or Miocene, which could be post-flood in some cases. I don't think so, though. I just think these are just varieties within the Genesis kind of the elephant or the mammoth type or mastodon. So I don't think, though, that you're going to have precisely a woolly mammoth. That's definitely a post-flood animal, and only the post-flood. I don't think you're finding one that's close to that be buried during the flood. But sure, you got to have the same kinds from the flood, from the pre-flood Earth, buried in the flood that are on the ark, and then differentiated after the ark. They left the ark, and species, genera, and sometimes different families. And then they would be this. They could be similar. You can be similar genera before and after in that case. So I don't really see that as a big problem. But did I get the question correct, though? Did I answer the question correctly?
Looks like
it. Did I understand the question correctly?
Yeah, he's basically saying, so I can put it up again, too. He says, there are mammoths below Mike Ord's boundary. So I guess below the Cenozoic. And
no, there's none below the late Cenozoic. There's no mammoths that are older than Pliocene, I don't think. So my boundary could see that this is the thing. People erect a straw man where I believe the boundary is at the Tertiary Pleistocene in the Cenozoic.
Right.
No, it's variable.
Right, it's variable.
Depending on the location. I say every location has to be analyzed on its own merits, and these 35 criteria can help you to determine, because some places are very difficult. So, yeah, that's helped me in determine it. But no,
it's not just a clean line. It's not just a clean line in the geologic column. It's variable.
No. We can't use the geological column as an exact representation of biblical history.
Right.
Especially the Cenozoic, which I have made a case, and I think I'm going to write a paper later on that amplify it. in the Rocky Mountain valleys, in the high plains, the top of this strata has been eroded, sometimes over 1,000 meters. So that fits in with the recessional stage of the flood. So what remains, whether it's called Cenozoic or Cretaceous or Mesozoic, is from the flood. So some of this Cenozoic would be from the early flood. And there's other evidence that would support that. But then the Cenozoic in the continental margin sediments and the continental shelf is from flood runoff. This would be late flood. And then you have the ocean bottom sediments, and they date these Cenozoic too, I might add. But they find what they think are ice rafted debris, whether they are or not, I don't know, that they claim are early Cenozoic. Well, we have to have glaciers and ice sheets down to sea level to form icebergs to float on the ocean and drop ice rafted debris. And so if these are in early Cenozoic, to me, they'd be post flood.
Right.
So the Cenozoic is at various times in biblical Earth history. There's not a one-to-one correspondence. I think creation scientists and others got to realize that we can't use the exact details of this geological column to pigeonhole biblical Earth history. And the Cenozoic is very variable. I think less so in the Mesozoic and Paleozoic. So that's one problem with this question. But I do understand that and believe that there are claimed some mammoths that I would believe would be from the flood, and then you have the certain ones that lived after the flood. So I do believe there are flood mammoths, but you'd have to look at the precise bones. I'm sure they're not identical to the woolly mammoth or even the Columbian mammoth, but there's some differences. But you'd expect the same kinds before and after the flood. So
Right.
See this is a minor problem. I need to work on it some more. I know that, but I see it just as a minor problem. Sorry about that.
No, that's a great answer. Very detailed. I see it as a minor problem as well, especially compared to the criteria that you've listed off, the 33 reasons why the boundary has to be higher, which I haven't seen necessarily engaged. But one thing you pointed out, and I think a lot of people forget, is that the creation event 6,000 years ago, God would have created populations of animals in fully working, functioning ecosystems. So we'd have populations of, you could say, the elephant kind, the canid kind, the felid kind. And so those 2,000 years of diversification, especially with more clean genomes, more genetic diversity, and the environmental conditions associated in the pre-flood world, like you said, you'd have very similar kinds pre-flood, very similar kinds post-flood.
Right.
So to correlate them the way that I find the KT boundary proponents are doing, I don't think is valid. And you said because the Cenozoic is variable, we have to look at each case independently.
Yes.
And determine it. Right. Okay.
Yep.
So that's key. Okay. Well, next question that comes in, and I appreciate that question there, Joel, and thank you for the response, Mike. Next question comes in from Cool Jesus, and he says, I think the biggest strength to the KPG boundary is actually, so a lower boundary, is actually that there is a global marker, he says, which theoretically a global flood would have. And if I'm not mistaken, I think he might be looking to the iridium layers as the global marker, Mike.
Yeah, okay. I might add there's a lot of global markers all through the Cenozoic geological column. And I did some research on that years ago, 20 years ago. I think there's more to this, these matching these iridium spikes, as you call them, as they're called, with the KT. First of all, the original one in Gubbio, if I pronounce it right, Italy, was just not a spike over a thin area, but you can find that high iridium through 4 meters. And I'm thinking that you probably have a lot of iridium. And iridium is just part of the platinum group metals. from impacts. And I think you could probably find a lot of spikes in a lot of places in the geological column. And so they just find the ones that are near the KT boundary. And sometimes they have to redate it a little somewhat to make a match. And that's a little bit of circular reasoning in that, I believe. Just like some paleontologists admit that the KT is defined as dinosaurs below and mammals above. And simple as that. That's a circular reason, because I've run into some cases of early tertiary dinosaurs and eggs and stuff like this, dinosaur eggs that are redated or claimed to be reworked, depending on whether you want to put it below or above this boundary. So there's some of circular reasoning in that. And same thing could be at other boundaries throughout the Mesozoic and Paleozoic. There's a lot of precise boundaries they claim are global. Yeah, I would question a lot of that. I think there's a general order in the geological column, but I'm thinking there's not a precise order in the geological column. And I found examples, and I've published them in especially the Journal of Creation. They're probably online. You can check creation.com and see some of them. And I think they've done that with the iridium layers. They've kind of moved them around, or the KT boundary lower to match the iridium layer. But I think these iridium spikes are sometimes they're not spikes; they're spread out. And I think you're going to find a lot of spikes throughout the Cenozoic and the Mesozoic, especially strata. But they don't look for them there because they don't expect anything like that there. Or maybe some have. It'd be interesting to see if someone got a whole Mesozoic sequence and checked for iridium spikes. Anyway, that's my somewhat rambling take on matching precise data. But there is a paleontological boundary there. Like, I believe that was part of the question. Yeah, dinosaurs below, mammals above.
Right.
Part of that is circular reasoning. They're now finding a lot of mammals in the Mesozoic that are fairly complex, not those little mouse or rat-sized ones necessarily. They find a lot of those too. And then, like I said, they found dinosaurs or dinosaur eggs in the early Cenozoic, very early Cenozoic, and somehow they get redated to the right Cretaceous level. But there's one situation, the San Juan Basin in New Mexico. I've not heard the results, but this guy made a good case in a special paper of the Geological Society of America, if I recall, of these bones in the Paleocene and the San Juan Basin being an example of dinosaurs that survived the KT. And he said they couldn't be reworked from the Cretaceous up into the Paleocene because they're big, huge dinosaur bones, which that's a good point. I have not seen anything more information on that, so I don't know what the status of that is, but that sounded like a pretty good case of post-KT dinosaurs. But there's a lot you can say about these precise boundaries, and I think I probably said enough rambling on.
No, that's good. And you've written extensively on this too. So I do want to recommend people to check out your articles on it. So I guess my question would be on that. If the iridium is variable with spikes in different areas and essentially not as neat and orderly as some might say, could this be attributed to bombardments just during the flood year in terms of meteors, but also the massive worldwide volcanism? Would that produce some iridium spikes as well? I guess, what are your thoughts on that, Mike?
At first, it seemed like that could be an explanation in the 1990s, I think, but probably not. I don't think the volcanoes would be a good explanation for iridium spike, but I believe there was a lot of impacts during the flood. How many? Not as many as I using the moon as an analog by far. I think maybe it's, I'll say around 1,000 impacts of various sizes. during the flood, and these would produce iridium layers in a lot of places. That would be the cause of iridium layers in the Mesozoic, Paleozoic. But they don't look for them there. But it'd be nice if they did, or in the Cretaceous. In fact, speaking of impacts, I have recently calculated that the two largest in the Proterozoic, about 2 billion years in the secular time scale, Redifort and Sudbury, they would probably destroy much of the Earth. Just not from the wind and the fireball, but from the global wildfires that'd start. But there's also, they found some huge impacts in the Archean based on spheroidal layers, widespread in South Africa and in Western Australia. And they claim those are as old as 3.5 billion years old and represent impacts of anywhere from 10 to 80 kilometer objects hitting the Earth in the Archean. This is getting into another subject where we probably better not get onto pre-flood boundary, but an area of active research on my part. So I think impacts are a big part of the flood.
Well, it makes sense too, because, and I guess this is my own thinking, but the global flood was a judgment by God. It was worldwide. Yes. In the end times, we're going to have another worldwide judgment by God, this time fire. But it seems like that we're going to have meteor bombardment as a form of judgment there too. So why not also during the flood? You know, it might apply to both. It seems. I don't know what your thoughts are on that, but if someone were to say, well, the Bible doesn't specifically talk about, meteor bombardments during the flood year, what would be a good response to that? For me, I'm correlating it to the end times judgment, but what's your thinking on that, Mike?
Well, as far as the end times judgments, yeah, a lot of those descriptions could be meteorite and bombardment, but I'm going on the secular impact record. The Earth Impact Database, haven't updated in so long, but I've got some recent information. There's about 200 confirmed impacts, but I'd say 30 of them are small and probably post-flood. So it appears that there's definitely 170 from the flood. That would be the Paleos that are in the Cenozoic, Paleozoic, Mesozoic, Cenozoic, and Precambrian. But they're missing a lot, and they're adding new ones all the time. And there's a lot of there's at least twice as many possible impact craters, but they haven't got the definitive proof on these. But I think a lot of these would probably be impacts. But then you have these Archean layers, or spheroidal layers from impacts. There was debate on that, but it's pretty sure they're from impacts now. And by the way, these I don't think can occur before the flood. It'd wipe out the pre-flood world. And so you add them all up and realize that the known 170 are mainly on the continents. Then we have the old ocean basins to consider. And some areas are poorly representative, like Antarctica and Greenland because of the ice sheet. And China's Eastern Asia are poorly representative. So that's why I'm thinking maybe around 1,000, about. This is within wide tolerance limits, but we definitely know there was flood impacts from the 170, a lot of them in the Paleozoic and Mesozoic and even the Proterozoic. So I think they're a big part of the flood. And we have strong, powerful evidence that impacts had to occur during the flood.
Right.
And I believe that all flood models have to consider them. And some flood models just have ignored them. And I don't think that's a good way to go.
I like the way that you've addressed it, and you've incorporated all the data essentially into your specific flood model. And here's a follow-up question from the same questioner. Okay. And he's asking, Mike's flood model seems to disallow the distinct biomes. So I think he's referring to ecological zonation that was briefly touched on earlier to be the primary flood/fossil sorting mechanism. What do you suggest in its place? Intelligence, question mark, hydrologic sorting, question mark. So I guess if I could reword this, do you find that having a higher flood boundary is contradictory to ecological zonation?
No, I don't quite see how it relates, but I'm probably misunderstanding the question. Let me see. Let me think. I do believe in vertical ecological zonation. I mean, we have a lot of marine fossils in the Paleozoic. We have some land fossils in the Mesozoic and mammal fossils. I believe in a general order, and this could be a vertical ecological zonation, and that strata that were deposited came from certain ecological areas. So you find just those certain organisms from those ecological zones. But I also think that there's not only a vertical zonation, I think there's a horizontal zonation across the earth, where in some areas you had certain ecological zone with certain organisms and other areas different, like forest. I think you had forests of angiosperms and forests of lycopods in different areas, horizontal zonation. And these get deposited in certain areas of the earth and not in others. For instance, the lycopods are mostly in the eastern coal seams found there, while the angiosperms from the Tertiary and Cretaceous are found especially in the western U.S. So that's quite a horizontal distance. So where they came from, and this brings up a lot of questions of where did all we've estimated 1,900 meters eroded off the continents, but we're trying to figure out how much is left. John Reed especially has been calculating how much is left of the continents using oil well and a lot of seismic data, all the data you can from state surveys, so state by state. And we've done quite a few states. He's done quite a few states. And we're getting to about 1,500 to 2,000 meters is the average left on the continents. So if you add, we'll say 1,900 meters left on and 1,900 meters eroded. So half the rocks that were deposited early in the flood got eroded off in the late flood. And that's 3,800 meters. So all that sediment's got to come from somewhere, from currents deposited just on the continents, but not the ocean basins. I got ideas, but I don't really want to share them now because I think they're too speculative without a lot of evidence. But it would address some of this ecological zonation stuff because they came from different ecosystems, from different currents, from different locations on the earth. Anyway, I don't know if I answered the question precisely. It seemed like it was a difficult question for me to understand, and I just have given some thoughts. Some of them are current research thoughts. Anyway,
Nope. It looks like you answered it good because the questioner did say that you tracked that question well. I asked if he wanted to clarify anything. He said that's good. Okay, so here's the next question. And I believe you essentially did answer this in your last portion of the presentation, but I don't think it can hurt to reiterate it a little bit since it seems to be one of the major objections from those that hold to a KT boundary, the distribution of some of these fossils. Okay. So Grayson has a question. He says, we have marsupial fossils in Australia from the flood, in your worldview, but none from the Middle East. So where are they if they were there to travel to the Ark?
Yeah, we have, there's only one location of early Cenozoic marsupials in Australia. That's in Southeast Australia. They call it Lightning Ridge, I think. But you find early Cenozoic marsupials on all continents, including Antarctica. And I believe these are from the flood. And so you had a lot of marsupials that were deposited in the flood. And then the ones particularly on Australia, they had to spread from the arc to Australia. Because I believe that the late Cenozoic ones clear down into the late Oligocene, which is just below the late Cenozoic. I believe these are post-flood. They had to come from the arc. And how they did that, well, in one article on Journal of Creation, I hypothesized that the marsupials spread to the post-flood oceans, which are about 66 meters higher at the end of the flood, because Antarctic and Greenland ice sheets had not developed yet. So all that water in those ice sheets would be part of the flood, sea level at the end of the flood, which would be approximately 66 meters higher. So they had to leave the mountains of Ararat and probably arrive to what we call the Indian Ocean. And I believe there's I don't believe the land bridge from Southeast Asia to Australia would be a good route, because there's a lot of wide straits that are deep. I don't think they could have crossed them. I think they came by over log mats, getting caught on log mats that would still exist in the post-flood time for a while. So that's how I explained it, but I admit it's speculative. The secular scientists have problems just as bad, I might add. How did they get to Australia? And I think some of them have thought about log mats. I better back up. I'm not sure about that, but
no, they have. Even to get on different continents, they've invoked rafting with a lot of your monkey species.
Oh yeah, for South America, that's true.
Right.
Like the caviomorph, can't pronounce it, rodents and the New World monkeys rafted over from Africa, and it had to be by log mats. But they don't have any log mats. They just have little vegetation from storms, and so they have major problems. But that seems to be the explanation that the secular scientists are going with nowadays, that they had to come across the Atlantic on these puny rafts somehow.
Right.
But Australia is different. I'm not sure that they used log mats or vegetation rafts to get them to Australia, but some of my reasoning why they had to be on log mats is because you find a lot of organisms that couldn't go across a land bridge, like snakes that are animals in the on Australia. You had to get the snakes there, and also the marsupial mole. No, that's a challenging one. I haven't got a good explanation for that yet, except that possibly the marsupial mole is part of a different kind that wasn't living underground, like fossorial. I think that's the word, but was an animal that lived on the ground, and then a variety within the kinds. You got to remember, after the flood, that it was kinds that left the ark. And the average kind, we believe, is about the family level, and so they differentiated after the flood into various genera and species. And so I think that's how you can explain the marsupial mole getting to Australia. I don't think that man brought the marsupials over, because a lot of these marsupials are carnivores. And I'm not sure that anyone leaving India, for instance, would take carnivores on a canoe or a big raft to Australia. And by the way, there was recently a pictograph of what looks like a marsupial found in India, published in the Journal of Creation, indicating that maybe they saw some marsupials that were left behind or something like that. But anyway, that's my hypothesis on it.
That's good. I think that's a very plausible hypothesis. Mike, I appreciate it. This one's an interesting question here. Might be slightly controversial here. Let me put it up on screen, because I think it has to do with the Precambrian boundary. Maybe I'll read it out and we'll kind of work through it together. So the questioner is asking, can you ask Mike if he has any thoughts on the pre-flood boundary. Ken Colson, he says, specifically presented a controversial paper at the ICC last year, and he says it had to do with stromatolite reefs and Precambrian. And if you have any thoughts on that, Mike.
Oh, I have a lot of thoughts on that subject. In fact, Peter Kleberg and I are starting a big analysis on stromatolites. Ken Colson also published an article on stromatolites in the Answers Research Journal earlier this year, saying he finds them in the Cambrian and the Ordovician, I think, in southwest Utah. And they're extensive. And you know, because of this, he puts the pre-flood boundary in the late Paleozoic, so that all the Precambrian and early to mid Paleozoic would be pre-flood. And I don't know of any creationists that have done that. He's the only one. It's because he's taken stromatolites, I think, too seriously. I did before he did his published his papers he's published papers in the secular journal on this topic. I've got them, and also the others that you're talking about from the ICC and the Answers Research Journal. I don't think he spent enough time looking at this, because I find a lot of indications that stromatolites are non-biological. And I published this in the CRSQ about 2008, and no one has looked at that. Some of the indications are that stromatolites are practically always found in carbonates. Well, those today, like Shark Bay, Western Australia, they're not necessarily carbonates. They bind sediments and particles of all types. So there's other things. And another big factor is that stromatolites are just not found in the early Paleozoic, where Colson did his research. They're found throughout the Phanerozoic, especially to Triassic. And so are we going to say because they're found in the Triassic and they're biological, and by the way, I don't think they can form in within a year. They're multi-year organisms. Are we going to say that stromatolites in the Triassic would eliminate the flood and put the pre-flood boundary up in the upper Mesozoic? No. What we need to do is analyze stromatolites to see if there's a non-biological mechanism, which some secular scientists claim there is. So Kleberg and I are going to do more research on this, but I definitely think that that Colson is jumping to conclusions too fast and not really analyzing to see whether all these are non-biological. That's my opinion, but I have a lot of other opinions on this subject, but we better stop there.
We could probably do another 3 hours just on that subject. So,
this is, like I said, it's research, part of research dealing with this, and Colson kind of I have to give him credit. He what is it? Touched off a spark in my mind.
He sparked some interest in terms of more.
I've always been interested in stromatolites. I got files that are about 1 foot high on stromatolites, but he's motivated. And by the way, Kleberg and I found some really interesting stromatolites in Glacier National Park last year. We found some really nice stromatolites in limestone, of course. The bulbous features, and then laterally they changed into layered sediments. So I think that's some evidence that these are biological, but they're just layers that are, and we don't know the conditions of what causes this yet. But on the other hand, some secular scientists even claim that these layers of they're all in carbonates, are stromatolites also, or something like it, stromatolite-like They don't necessarily have to be bulbous like a mushroom, but can be even flat. The definition of a stromatolite is a big problem too. So anyway, that's some thoughts on that. But to summarize, I believe because of impacts and other features, like the phosphorite graph I showed, that the pre-flood flood boundary is not at the Precambrian, Cambrian, like many creationists believe, but it's way down, and that includes Precambrian sedimentary rocks. Most, if not all, Precambrian sedimentary rocks, I believe, are early flood, formed in rifts and basins during a high turbulent beginning of the flood. So that's my opinion on that, and I've written papers that are not published yet. Some are, one long ago, but research I'm working on that's either submitted or in press. So I'll have more to say on it in about a year or two.
Well, I appreciate that, Mike. That's why it's so much fun being a young Earth creationist, because we have endless topics to research to keep us busy, to keep our minds occupied. I've personally spent hours and hours reading your articles and papers. So, okay, well, thanks for that response. Next question here comes in from Cliff Matthews, and he says, "Hi, I'd like to know Mr. Ord's view on the crustal boundary shifts that have happened during secular variations." In brackets, he puts a couple examples. He says the Henrik, hopefully I said that right, Henrik bond cycles now being researched in a myriad of papers by NASA, ESA, and China. Do you have any thoughts on this at all, Mike?
Crustal shifts over the mantle, or what? I'm totally unfamiliar with those papers or that idea in secular. I try to keep up in 50 earth science journals at Montana State University, but I've never run across that yet. Can he elaborate a little more on what he means by crustal shifts?
He did say, so he did clear, he said yes over the mantle.
I don't know. I haven't come across that in any of the geological journals I read the table of contents of to check them out. If I see an interesting article, I'll actually copy it. I have no idea what anything about that. I don't. My gut level feeling is that it'd be very difficult unless the lower crust was fluid-like, or what's the word? Soft. Okay, there's another word for it. I can't think of the precise geological term.
He did say the catalyst for this is solar microflares. I haven't personally read up on this either, so I can't really
solar microflares. I can't see the connection. I'm sorry, and I haven't run into any. Can he give me a paper to check in the library?
Absolutely. Cliff, if you want to email me a specific paper, I could always email that to you, Mike. And but that's good for now. Let me move on to this one, because this one seems to be an interesting question that pertains directly to, let me see here. We got a lot of questions that came in. Okay, here it is. And it pertains nicely to the flood boundary question. And he is asking, oh, maybe I lost it again. Oh, no, here it is. So the questioner asks, it's a question pertaining to the cetacean fossil record. So it has to do with whales. And he is asking how you would explain, according to your higher flood boundary model, the fact that he's saying there's 0 whale or whale ancestor fossils across continental Africa, Australia, Russia, China, and so on. Do you have any thoughts on that, Mike?
I think there are Cenozoic whales that are from the flood. They have an interesting distribution. I must say that I have not delved into it as far as them being lacking around as fossils around Australia and the other places he mentioned. But I definitely believe that a lot of whales are from the flood, and there's whales post-flood. I definitely don't believe that some terrestrial creature became a whale in the Tertiary, because that's when it happened. About early Tertiary, 55 million years ago, if I recall, is when they believe this occurred. I don't think that occurred at all. In fact, you can find a number of articles on creation.com and probably the Answers in Genesis.org website about all these whale fossils,
Right.
that they claim are transitional. I think there's some major problems in that whole area from a secular point of view, and so I believe there aren't any real transitions. That there's a major gap there, but I believe that there's whales that are from the flood and post-flood. And as far as their distribution, at this point, I don't have an answer to that.
I've read an article from Dr. Tim Clary, who, correct me if I'm wrong, holds to a higher flood boundary as well.
Yeah,
And
same as me.
And he's pointed out whale fossils that are located on the coastal margins of nearly every major landmass, and that they're also found across the entire continent of Europe. And so that would seem to support the higher flood boundary model that we're discussing today.
Yeah, that's right. He has an article in Acts and Facts on that. It's probably online. Yeah, I remember that article. They're found in quite a few locations, especially coastal areas. But the questioner said they weren't around Australia and a few other places, which I don't remember. I can't recall right now. But
Right.
I don't know if Clary addressed that or not. But he has addressed that particular whale. I'd suggest that the questioner check the ICR.org website, is it?
Yeah, I just found the specific article I think you're referring to here. Whale fossils confirm post-flood boundary.
Okay.
And they do make an interesting point in it. And I guess we kind of touched on this earlier, Mike, but to hold to a lower flood boundary model and therefore say that all your whale fossils are post-flood, then unfortunately, I think as some have proposed, you would have archetypes that are basically walking whales that would evolve into your marine whales. And so that would not just require, as we've been talking about, Mike, where we've got the pre-existing ability to adapt after the arc, right? You go out into the world and you can vary based on the pre-existing diversity. But to go from an arc walking whale to a whale suited for the ocean environment, that would take novel macro evolutionary changes, if I'm not mistaken on that.
Yeah, right. And speaking of macro evolutionary changes, Michael Denton, I don't have his book handy, but he wrote a book just recently saying there are 100,000 unique organs in all the biological world, if I'm recalling him right. 100,000 of which I think features of the whale would be at least one of those, maybe a couple of those major features. And he said that they aren't led up to by any transitions to those major organs or features. And so it's a major gap that I believe that it's a gap that I think that the secular scientists are trying to fill. But I think that they're, when you analyze this data, and you can check creation.com and answersinresearch.org and maybe ICR.org, you'll find out that what they're claiming just isn't so, that it's still a major gap, just like all the gaps to these other 100,000 organs of other animals that don't have transitions to. So Anyway, that's a thought that came into my mind about that subject.
Well, speaking of transitions, or I should say so-called transitions, where would we, as proponents of the late Cenozoic and oftentimes variable flood boundary, where would we fit the so-called horse series, or at least the fossils associated with the horse series? Would that be pre-flood, post-flood?
In the fossil record, you find a lot of three-toed horses,
Right.
but in the Ice Age, you just find, as far as I know, one-toed horses. And so I think these three-toed horses are from the flood. But the Cenozoic horse record, there's a huge variety: size, toes, teeth, and a lot of people have commented, despite what you see in museums, that it's not a straight line change from the little guy, Eohippus, I think it's called, up to Equus. That it's a big bush and a massive variety of horses, and that you really don't have a linear sequence, despite a lot of museum displays, which are, to me, propaganda in the horse series.
Right.
But I think that practically all these horses are from the flood, and only certain horses, which aren't a big variety, by the way, are post-flood. Just a small number are post-flood, I believe. And you find a lot of horses in permafrost of Alaska, and some in Siberia. That'd be from the Ice Age. And there's not a lot of variety from based on the present one. There's differences in sizes. In fact, just from genetics, you can we get horses which are the size of a large dog now.
Right.
So yeah, there's a lot of genetic variability still in those horses, but I think the vast majority of horses you find in the Cenozoic are from the flood.
Therefore, would you argue, Mike, that in the pre-flood world, and I want to compare it to today's world, we actually oftentimes find more variation within the same species today than across species. And so if the fossil record is telling us that there is even more variation in what we would say is the pre-flood world, we could have all kinds of horses, all kinds of a variety of horses, but at the flood, only a very small subset of that overall variation was brought on the ark. I mean, you're only getting 2 of each kind, 7 of some.
Probably, yeah.
Right.
I think in many cases, especially with the horses, you can say that. I think with the elephants, which I've looked into somewhat, you can say that, because we have all huge variety of Cenozoic elephants that would be, I would say, flood, but only certain ones we see post-flood. Mastodon, straight-tusked elephant that's found in Europe, mammoths. And now they claim there's gomphothaurs, which is a variety of elephant that is post-flood, but they used to be considered mastodons, and I think that's what they really are. There's not a lot of big variety among them. In fact, it's been shown that the woolly mammoth and the Columbian mammoth are just varieties within a species, but they define them as different genera. And the African and Asian elephants are defined in different families. Different genera and I think different families or different. Anyway, they're pretty far apart, but we know that they've been able to interbreed successfully. That happened by accident in a zoo. So there's a lot of confusion, I think, and when it comes to fossils, that's part of why my opinion on fossils. Anyway. I hope that answered the question.
No, that's good. I've heard some young Earth creationists who hold to the KT boundary model suggest that your one-toed horse of today essentially evolved from your three-toed horses that we would say were from the pre-flood world, drowned in the flood. I think they would say that this evolutionary series happen after the flood, if I'm not mistaken. I don't want to misrepresent them though.
Yes,
But
they would if they believe the Cenozoic is post-flood, because all those horses would be post-flood, and there'd be no horses from the flood.
right. So for us, would we say, as proponents of the higher flood boundary, that your one-toed horses would just be a subset of the overall variation in the horses pre-flood, and therefore your one-toed horses didn't necessarily evolve or devolve from a three-toed horse? Do you have an opinion on that, Mike?
No, I think it's just varieties within the kind, and
Right.
I think there might even be the possibility of a three-toed horse. You can genetically engineer it, but I haven't heard anything about that. It's possible, but the genes might still be there. But in general, in the Ice Age and today, you just practically always see, if not always, one-toed horses. And I don't think it's an evolutionary scenario. As secular scientists admit, it's a big bush. It's not a linear evolutionary scenario from that, what's called that Eohippus, which some people don't even think is a horse.
Right.
From that up to the Equus, the one-toed horse. So anyway, in my scheme, I would put practically all those, and there are a lot of three-toed horses in the Cenozoic, and I'd put them as the flood.
Yeah, I would too. I think that's a great answer and position, Mike. So here's the next question that comes in. This comes in from Doki Doki Bible Club. Thank you for your question. And Doki says, is the presence of widespread chalk layers showing the end phase of the global flood?
I don't think so. Not the end phase, but a phase during the flood. I don't know whether you can correlate all those chalk layers around the Earth to a certain period. I have seen chalk in southern England, Israel, and in Kansas. And the ones in England are coccoliths, and I believe the ones in Kansas are not. And I think they might be foraminifera. So I think you have a variety of different organisms forming chalk. I'd have to look that up, but regardless, they're kind of far apart geographically. So they're dated the same though, Cretaceous. In fact, the word Cretaceous, I think, is mainly focusing on chalk, but I don't know whether I wouldn't say they formed at precisely the same time in the flood in various parts of the earth. I think what they are is massive blooms of microorganisms of particular types that got deposited, and then I believe, like for instance, the ones in Northwest Europe, not only in England but France, that they got redeposited by mass flow moving along the bottom of the ocean. But this is still an area of active research in creation science. The secular scientists have their own problems.
Right.
The purity of that chalk, for instance, is one big problem. And the interesting thing, it has what's called flint nodules in it, which is similar to a chert. I've seen all this stuff, and we do have work, but I think most creation scientists, and I think Andrew Snelling started it off with this model of massive blooms. And there would be massive blooms during the flood, because in the flood you had not only some powerful horizontal currents, but you had massive vertical overturn of the ocean in places. And if it's anything even slightly like today, you have a vast amount of nutrients on the deep ocean, which probably not as much as during the flood, but probably some. And as you bring up these nutrients, that's what you need for massive blooms. And these blooms can occur very rapidly for massive amounts of these microorganisms that would live and die very quickly. I think that's a reasonable model, but it needs refining and more work. And these other chalk layers need to be figured into it. And I don't think any creationist that I know of has dealt with that issue. There's many creation questions. Like I said at the beginning, I believe we have the big picture of the strata over large areas with little or no erosion between layers, indicating quick deposition, many layers over large areas. We have the big picture. It's working on these finer details,
Right.
That we need, that we're focusing in on, and we're sophisticated enough in creation science to have different opinions on these. It's not just one monolithic idea on these. It is either right or wrong. It's got different ideas, which we need to refine on the principle of multiple working hypotheses.
Right. You just read my mind, Mike. I was going to say that I love your multiple working hypotheses point. And that's one way that we're going to advance in young Earth creation science and flood geology is by having multiple working hypotheses, but also this type of in-house dialogue, healthy discussion, healthy debate. One example here is the flood boundary issue. And you've been very scholarly in your approach to this specifically, Mike, because in your hour-and-a-half presentation, again, I want to point out, especially to the audience, anybody who just got here, you provided overwhelming evidence, in my opinion, for a late Cenozoic flood / post-flood boundary. But you also spent a great deal of time addressing the criticisms and objections to that flood boundary. And that's really excellent.
Yeah.
Okay, I want to be cognizant of your time. As always, Mike, time flies by with you. I could talk to you forever. This has been a great show.
Yes.
I'm going to wind it down with one or two final questions here.
Okay.
And again, I'll let the audience know, I understand a ton of questions have come in, but you could find probably over 20 to 25 hours worth of content with Mike Oard here in your 9 shows you've done with myself and George here a lot of the times as well. We always go 2 to 3 hours. So there's a lot of discussion there for people to see.
That's fine.
I always appreciate your time and answers, Mike. So this question comes in from Joel Duff again, and he's asking, how can a global flood explain a layer of sediment that's not mixed with other layers?
Okay, a layer of sediment not mixed with other layers. That's a good question. The layering, I think there's several ways to produce layering over at least local scales. I think distal turbidites can layer out into distinct layers, and some of them can look very even. I also think that we can layer things out by what's called internal waves. You form waves on any interface density interface. For instance, the surface of the ocean, find a lot of waves, but we find them in the deep interior of the ocean too. As currents hit a boundary and they form waves. A lot of these waves impinge on the bottom and will erode and deposit sediments of different shapes, densities, and masses. And I think we can form layers that way. So in the flood, I have an article on this in creation.com if the person wants to check it out on internal waves. I forgot the exact title of it. But during the flood, the speed of the currents, the turbulence, I mean, you'd have millions of internal waves. Some of them would go long distance, and they could spread fine layers over large areas potentially. So these would be 2 mechanisms I could think of to form fine layers over large, if he's talking about fine layers, but thicker layers like sandstone, carbonate, shales, they can be explained by shifting currents from different regions, for instance, or facies changes from a coarse sand as it moves along, it's deposited, becoming a fine sand, finally a silt. You have horizontal facies changes. So we have potential to explain all these. I think that the secular scientists would consider them varves, but off the top of my head, I think there's some problems with some of these varves. For instance, in the Green River Formation is claimed to be 6,000 fine varves, very millimeter scale. They believe they're varves, but you find a lot of organisms, fish, stingrays, other such features in the Green River Formation that would be deposited, and then they would be the thickness of maybe 100 of these so-called millimeter scale varves, and the fish would rot before the 100th one was deposited. So there's problems with organisms in these fine sediments. So we got potential, but I think secular scientists have problems too. To sum it up, I don't know if I answered the question precisely as the questioner asked, but I appreciate the question.
Yeah, no, I think that's good. We've had a lot of great questions this evening, and we've had a good amount of people on both sides of the argument, it seems. So this has invoked some healthy and sophisticated dialogue, which is oftentimes my goal. And you mentioned the Green River Formation. We did a 2+ hour show on that, actually. That's another controversial issue. And correct me if I'm wrong, Mike, some would argue for the Green River Formation being post-flood, others the flood. And this basically applies to the flood boundary, isn't that right?
Yes. Was I part of that, or was that from someone else, that presentation?
Yeah, that was you. That was you, me, and George did that.
Okay, yeah. I'll just sum up about the Green River Formation. Even though it has 6 million of these fine layers, they claim in certain, at least in certain parts. I don't know if they correlated from various areas that they claim are varves. But when you look at the Green River Formation as a whole, which some creation scientists believe is from a post-flood lake, partly because it's in the early Cenozoic, so it's automatically post-flood to them, but they have other reasons. And I've gone through this with some of them. But my major reasons that I believe it's from the flood is the area of this. It's, I think, 40,000 square kilometers in several basins within the Central Rocky Mountains area. And the thickness averages probably several thousand feet thick. In some places, it's, I think it could be 20,000 feet thick in just south of the Uinta Mountains in the Uinta Basin. So these would be difficult to explain after the flood. And not only that, you have tropical fossils in it, like palm fossils, crocodile fossils, which, how are you going to get such warm climate fossils in the interior part of the western United States, far from the ocean, at high altitude, straddling the continental divide, 6,000 to 8,000 feet altitude, and get these warm climate fossils after the flood, especially if you have volcanic winter at times. Not only that, there's enough oil in the oil shale to supply all the energy needs of the United States for 100 years. How would that oil, which is an example of tertiary oil, by the way, how would that form in a post-flood lake or lakes? I know the big picture to me says that the Green River Formation is from the flood.
I agree. And you, I think, demonstrated that sufficiently in your Green River Formation program you did with us. That was comprehensive. If I haven't really seen any strong rebuttal or objections that have come into that show. So in my opinion, there's another point for the late Cenozoic flood boundary. Okay, so I'll wind it down here because I've got one super chat that came in, which is basically just support for the show. So this comes in from Jamie Russell. I appreciate your support. and he always feels blessed by your information and presentations here, Mike. And he's asking, what is Mike Oard's favorite discovery or body of work that he thinks should impact non-believers, his own and others for end?
Okay, what is the major thing that would impact non-believers? Whew. My mind's kind of drawing a blank, maybe because it's getting late.
Yeah.
Let me think. The one major that, when I started off at the beginning, I think as far as impacting non-believers, that's the major feature that, in sediments and fossils, the big picture demonstrates the flood. And I think that's powerful evidence, like the Tapete sandstone, which up in my area is called the Flathead sandstone, given different names in different states. That in itself, and by the way, it's a strata in fossils where they try to demonstrate evolution or the flood didn't exist and uniformitarianism. But we could take that big picture of that strata and fossils and say that the big picture supports the flood and not slow processes, small processes of deposition over millions of years. I haven't worked on that too much. I have kind of added to it by emphasizing the Flathead sandstone up in Wyoming and Montana where I live. But I haven't added a lot to that. This is other creationist geologists' work. And I would say that would be the major piece of geological evidence to challenge skeptics and secular scientists that, hey, the flood could explain this. This is for evidence for the flood. So,
amen. Well said. And all of this evidence that you have provided for us in these number of presentations, they're testimony to the existence of God, to God's judgment, and to the reliability of Scripture.
Right. Amen. Reliability of Scripture.
Amen. Well said. I mean, it's 2 Peter 3 that says in the last days there's going to be scoffers denying the world that then was, being overflowed with water perished. And what are we doing, Mike? We're battling the critics that deny that very thing that was predicted. So
yes, interesting. Yeah, and this is all happening in the last days, which started about 1800, or actually in the late 1700s.
Right.
Whole uniformitarianism thing, even though it wasn't defined before Hutton in 1795, but they were using the principle clear back into almost the mid 1700s. So, and that'd be part of the last days. So we're in the last days, but are we in the last days of the last days? That's the big question.
That's the big question. So I guess my final question for you that comes directly from myself, for those young earth creationists that are expecting a really nice, neat, straight line in terms of the flood boundary, are they making too many uniformitarian based assumptions, the way that Charles Lyell, for example, predicted the ordering of the fossil record, the sequence of the layers? Do you have any thoughts on that? Because I know you're explaining how it's variable. It's not exactly as a lot of your uniformitarian or actualists, as they like to say, scientists would.
Yeah, actualists. Yeah. I have a lot of thoughts, but I don't know whether they're following too much uniformitarianism or not. Some cases I think they are. But as far as a precise boundaries, I believe they're taking the geological column too seriously, especially the Cenozoic. They look towards, for the geological column to be a worldwide sequence, it has to apply worldwide. But you can't show that they're worldwide connections. You can show it on a regional and local scale. And the typical example is the Grand Canyon and the Grand Staircase. The Grand Canyon will start in the Cambrian and it'll be missing the Silurian and Ordovician, I might add. There's a gap of 160 million years missing. Flat contact, by the way, no sign of erosion between the Muav limestone and the Cambrian and the Redwall limestone. And then that's the Paleozoic. Then you go up into the grand staircase, you got the Mesozoic. They're all flat. By the way, I might add little deformation. They had to be deposited when all the chaos of the early flood had to settle down, I think after day 40. Otherwise, you'd have faulting and all kinds of deformation in there. So in the grand staircase, you have the Mesozoic, and at the very top, you have a little bit of early Cenozoic, which is called the Clarion Formation. But early days, they never thought of a Cenozoic. It only became Cenozoic, I believe, in the last 70, 80 years. Don't quote me on that. I might be wrong. But that would be their sequence of the geological column. And even though they're a little horizontally distanced, you can tell that it's a nice sequence from Paleozoic up to Cenozoic, early Cenozoic. So they use that. Hey, it's there. But then they extrapolate that globally. You can't do that. It's fine for there. You got to show that these precise definitions, like the Permian, that this is a layer that's global at the same time in the flood and biblical Earth history. And I don't think you can do that. You can show it on a local and regional scale, and it fits pretty well in the Rockies, which I've seen, up to the early Cenozoic, and then after that you got big deformations in the mid and late Cenozoic, huge tectonics. So I think they take the geological column too seriously, and will say that, and they've accused me of saying, well, the post-flood boundary must be at the Pleistocene boundary. Pleistocene being the Ice Age and Pliocene being from the flood. But no, I think it's a lot of cases it is, but a lot of cases it's not, because we can't have a precise line. And it's because they're taking the geological column too seriously, especially the Cenozoic. So that's my summary statement on that.
Well, that is the perfect answer to that question, Mike. I totally agree. And therefore, probably the best way to wrap this show up. Very important. I'm glad that we were able to clear up a lot of the straw man arguments as well, Mike.
Hope so.
I mean, a 3-hour program dedicated specifically to the flood / post-flood boundary should definitely clear any of that up. We've had a great chat, tons of questions. So I want to thank the audience for being so engaged in this important topic. And I want to encourage you guys to share this around. Critical thinking is important. And this topic, of course, is important. Mike, you've done so much great research into it. And again, I thank you so much for the time you've given myself, you've given the audience tonight. So I just want to hand it over to you. If there's any final words, final thoughts, any last things you wanted to say, Mike. And looks like we're gonna wrap it up at the 3-hour mark. So this has been great, brother.
Well, I just hope and pray it's profitable to those that listen and those that weren't convinced. Think about it, please. And those creation scientists that are critical of or skeptical of what I believe, please examine the arguments closely and publish. That's the scholarly approach I think that you need to do to clear up this situation. And I've gone into your arguments. And by the way, there are more fossil arguments that you haven't even mentioned. These people that I've been thinking a lot about, and maybe one of these days I'll write a paper. But I have so much to do. Like I tell people, I have 500 years worth of research left to do. And but anyway, please, for the skeptics of my position, look into it, examine it, and publish it. See what you can come up with, and we'll go from there. That'll advance it. That's a scholarly approach.
Amen. Take the scholarly approach as you have done. You've written so much. You've given so much great data here in 3 hours. So those are some great final words and final thoughts there, Mike. Thanks so much for doing this again. I look forward to having you on again in the future. To anybody in the chat, everybody that's saying that they enjoyed this so much, please check the description box where you can find more from Mike, his website, his articles on creation.com, and also a playlist that I've created. You can find it on the website and also on the channel itself. It's titled Mike Oard on Standing for Truth, and you'll find 9 programs with Mike to enjoy. So with that, thanks again. Thanks again. Thank you, Mike. God bless. And Donnie is out.